Yeah, hi everyone, welcome to PrepFusion. So in this video, we are going to study about residues. In the last video, in the end, we studied about singularity. I hope you have revised the last lecture. Singularity, four kind of singularity we have seen: essential singularity, removable singularity, multiple pole, and simple pole. These are very important to understand. If you understand these singularity, then only you will be able to understand the meaning of residue. Okay, because residue you find out for the singularities only. What I mean to say is that, let's just say your function f of z is given, which is having singularities at some points. It is having singularities at points, let's just say z equals to z1, z2 and z3. At these points it is having singularities. So you will find out residue of f of z, residue of f of z at z equals to z1, at z equals to z2, at z equals to z3. So it is written in this manner: residue r of function f at z equals to z1, residue of function f at z equals to z2, residue of function f at z equals to z3. This is how it is shown. Is that understandable to you? Okay. How we will show? How we will show it? We will show it by r1, r2, r3. Residue of f of z at z equals to z1, residue of f of z at z equals to z2, residue of f of z at z equals to z3. Now the question would be, sir, what is the meaning of residue and where it will be used? Why we are studying it, where it will be used, and what is the meaning of residue? So that you will understand when you study complex integral, which is our next video. So in this video, I will tell you certain method how to find out the residue, but you will always have this question that, sir, where it will be used, why we are finding it out. So where it will be used, that you will understand in the next lecture. Are you able to understand this point? So this is like a prerequisite for the next lecture, but don't treat it as a prerequisite. This is the most complex topic of this particular chapter, which is our complex analysis. So in complex analysis, people struggle in this topic only. Okay, they always mess up about the singularities and they will mess up about the residue as well. Singularity we have already studied in 4 classification. Now we will talk about residues. Have patience, listen to me carefully, and you will be able to solve it. Okay. So with the what we had 4 kind of singularities. No, simple pole. We had 4 kind of singularities: simple pole, removable, multiple pole, and essential. So all 4 kind of singularities have different method of finding residues. So we will take the cases. Our first case would be about the simple pole, second case would be about a removable pole, third would be about multiple pole, and fourth will be about essential singularity. Okay, 4 cases, 4 different method of finding the residue. So for simple pole, let's see the method. Where is the simple pole here? Sir, the singularity would be at z equals to 1. In this f of z, that singularity will be at z equals to 1. And sir, this singularity is simple pole singularity. Right? This singularity is simple pole singularity. What does that mean? That means you need to find out residue of f of z at z equals to 1. This is what you are supposed to find out. So who is creating the problem? Z equals to 1 is creating a problem. So what you will do, residue of f of z at z equals to 1 would be equivalent to limit. Who is creating the problem? Z equals to 1 is creating the problem. No? So limit z tending to 1. You will multiply your function f of z. You will multiply your function f of z with factor of z minus 1. Why z minus 1? Because sir, the problem was there at z equals to 1. If the problem was there at z equals to a, then I would have multiplied with z minus a. Simply take this a this side, what you will get? Z minus a equals to 0. Forget about this 0. You will multiply your function with z minus a. So I will multiply my function with z minus 1. Multiply with f of z. So this is what you are supposed to find out, and that will be the answer of your residue. What will be the answer? Sir, limit. Where is the problem? Sir, problem is at z equals to 1. So limit z tending to 1. You will multiply your function with z minus 1. You multiply this function with z minus 1. What you will get? Multiply this function, which is z minus 2 upon, sorry, z plus 2 upon z minus 1. This is being multiplied with z minus 1. So this and this get cancelled out. Because this you take this side, this will become z minus 1 equals to 0. Z minus 1 equals to 0 means you need to multiply with the factor of z minus 1. So this and this get cancelled out. Put z equals to 1 here. What is the answer you are getting? If I put z equals to 1 here, because this and this is getting cancelled out, z equals to 1 if I put here, what is the answer? I am getting 3. So this is the residue. This is the residue at z equals to 1. Residue at z equals to 1 is 3. In the examination, will you do all this process? No. In the examination, how will you think? Sir, I need to find out the residue at z equals to 1. Sir, I know that, sir, this guy is creating the problem, no? This guy is creating the problem. So what I would do? Sir, limit, I need to find out the residue at z equals to 1. So limit z tending to 1. This guy is creating the problem. So remove this guy. Remove this guy. What you are left with? Z plus 2. Simply put 1 here. What is the answer? 3. That's it. Within one line, I will be able to find out the residue. I will not write down all these things. What I will see, sir, z equals to 1 is creating the problem. Remove this guy, put z equals to 1 in the rest of the part. Let's see this example. Here, how many singularities we are having? Sir, singularities we are having at z equals to -1, z equals to 2, and z equals to -4. 3 singularities we are having. Sir, all are simple pole. All are simple pole. All are simple pole. So first of all, what we will find out? First of all, we will find out residue at z equals to -1. Okay, so I will call it R1. Residue at z equals to -1. So limit z tending to -1. Who is creating the problem? Sir, this factor is creating the problem. When you are talking about z equals to -1, at that time only this factor is creating the problem. No, let's just say in this expression, if I put z equals to -1, so -1 square minus 2, it will become -1 divided by this will become 0. What this will become? This will become -3. This will become +3. No problem here. But this guy is creating the problem. No, when you are putting z equals to -1. So who is creating the problem? This guy is creating the problem. No, so remove it. Or what you can say, sir, if I take z minus 1 this side, it will become z plus 1 multiply with f of z. So eventually what you are getting? Limit z tending to -1. Who needs to be removed? Z plus 1 will be removed because this guy is creating the problem. So z square minus 2 upon z plus 1, z minus 2, sorry, z plus 1 is removed, no? So z plus 1 will be removed. Z plus 1, z plus 1 will be removed. So z square minus 2 upon z minus 2, z plus 4. So simply put z equals to -1 here. If I put -1 here, what it will become? 1 minus 2 minus 1 divided by -3 into 3. So answer is 1 by 9. Right? If I put -1 here, 1 minus 2 will be -1. This will become -3 and this will become 3. So answer is 1 by 9. So residue at z equals to -1. Similarly, you need to find out residue at z equals to 2. So residue at z equals to 2 will be limit z tending to 2. Who is creating the problem? Z minus 2 is creating the problem. Multiply with f of z. Right? Because residue is at z equals to 2. No? So limit z tending to 2. Z minus 2 is creating the problem. This guy is creating the problem. I will remove with this guy. What I will be left with? Z square minus 2 divided by z minus 2 is creating the problem. What you are left with? Z plus 1 into z plus 4. So z equals to 2 you are supposed to put. If you put z equals to 2 here, what you will get? 2 square will be 4. 4 minus 2 divided by 4 minus 2 will be 2 divided by 2 plus 1 3 into 6. Right? This will become 2 plus 1 3, 2 plus 4 6. So what is the answer you are getting? 1 by 9. Here as well 1 by 9. So are you able to understand this point? What I feel is that if you are having enough practice, no, then directly this answer you will be able to write down. What you will think, sir, z equals to -1 will create the problem. So I need to remove this guy and I need to put a -1 here. So if I put -1 here, sir, this will become -1 by 9. So this will become -1, upper side will become -1. If I put -1 here, sir, this will become -3, this will become +3. So -3 into +3 will become -1 by 9. So answer is 1 by 9. Okay, directly you will be able to write down this step. For z equals to 2, sir, this guy will create the problem. Remove this guy. Z equals to 2, I am supposed to put. So 2 square minus 2 will be 2 divided by 3 into 6. What is the answer? 1 by 9. 1 by 9. For the next one, what you will do? Sir, who is creating the problem? Sir, z equals to -4 is creating the problem. Z equals to -4 is creating the problem. So remove this guy and put z equals to -4. Z equals to -4. So 16 minus 2, sir, will be 14. What I am putting? Z equals to -4 here. So sir, this will become -3 and -6. So what I am getting, sir? 14 by 18. That would be nothing but 7 by 9. That's it. This is how you can do it. But here we are making the fair notes. So I will write down in fair manner. So answer would be residue at z equals to minus 4. That would be R3 limit z tending to minus 4 z plus 4 f of z. Limit z tending to minus 4 z plus 4 z plus 4 getting cancelled out, z tending to minus 4 you need to put, so minus 4 16 minus 2, or let's write down this factor z plus 1 into z minus 2. So 16 minus 2 will be 14, minus 4 square will be 16 minus 2 will be 14. Now this is minus 4 plus 1 will be minus 3 and minus 6. So 14 by 18, 7 by 9. Eventually you will have to do the sum, okay? Eventually you will have to add them up. So what will be the addition? Addition will come out to be 1. 1 by 9 plus 1 by 9 plus 7 by 9. In the next lecture you will have to add them up. Sir, when we will have to add them, that I will tell you. So what will be the addition? Addition will be 1. So this is the way of a simple pole. Very simple process, very straightforward process. Sir, simply who is creating the problem, remove that and just put the singularity. Singularity is z equals to 1, put z equals to 1 here, get the answer. Here there are 3 guys, sir. First this guy is creating the problem, I removed it, put z equals to minus 1. Then he was creating the problem, I removed it, put z equals to 2. Then he was creating the problem, sir, I removed it, put z equals to minus 4, get the answer. Next question, solve this one. So you need to find out that, what you need to find out? You need to find out a singularity first, because if you need to find out residue, that means you need to find out singularity first. What will be the singularity? So z square minus z equals to 0. If I solve it, I can see here it will become z minus 1 into z plus 2. Say yes or no? Yes. Can you do the factors? Surely you can make the factors. Say yes or no? अरे गलत कर दिया क्या भाई? Z square minus 2z plus z minus 2, right? So z plus 1 into z minus 2. Sorry guys, z plus 1 into z minus 2 equals to 0, right? So there are two singularities, z equals to minus 1 and z equals to plus 2. So can I write down my function f of z in this manner? Z minus 1 upon z plus 1 into z minus 2. Now the same question, singularity at z equals to, sorry, not singularity, residue at z equals to 1. Residue at z equals to minus 1, not at 1, z equals to minus 1. What that would be? Sir, limit z tending to minus 1. Sir, this guy is creating the problem, I will remove it. What I will be left with? Z minus 1 upon z minus 2. So if I put minus 1 here, this will be minus 2, minus 3, answer is 2 by 3. Right? I simply put minus 1 here, minus 2, minus 3, answer is 2 by 3. Now residue at z equals to 2. So R2 limit z tending to 2. Who is creating the problem? Sir, this guy is creating the problem. Z minus 1 upon z plus 1. Put 2 here, 1 by 3. That's the answer. Okay. Now there is another method to it. There is another method. But this method also works only for simple pole. Method 2. It is very important as well. This method is important as well. And it will work only for simple pole. For simple pole only. For simple pole only. For simple pole. For simple pole only. So f of z is given. Okay. F of z is given. You already know that I have the problem at sir z equals to minus 1 and I have the problem at z equals to 2. These are my problems. So what you will do, first of all you will find out f of z is written in this manner, no? Numerator by denominator. Numerator by denominator. What you will do is that you will keep numerator as it is. Now you will find out a new factor which is phi z. In phi z what you will do, numerator as it is and you will differentiate the denominator. Numerator as it is, differentiate the denominator. And after differentiating the denominator, you will put your singular point. If you need to find out residue at z equals to minus 1, then you will put z equals to minus 1. If you need to find out the residue at z equals to 2, then you will put z equals to 2. Okay. Here you will put singular points. Okay, let's see it by the example. Let's see it by this example only. I need to find out a factor. I need to find out a new function which is phi of z. What I will do, I know that sir, there are problems on these two guys. So let's keep numerator as it is and differentiate the denominator. When you differentiate the denominator, what answer you are getting? When I differentiate the denominator, sir, the answer I am getting is 2z minus 1. 2z minus 1. This is what I am getting. Okay. So now I am finding the residue at z equals to minus 1. Residue at z equals to minus 1. So what I need to do? Sir, in this factor, whatever the new factor that I have made, I just need to put z tending to minus 1. Residue at z equals to minus 1. That means limit z tending to minus 1. In this factor, simply put z tending to minus 1. What answer you are getting? If you put minus 1 here, what answer are you getting? This will become minus 2. This will become minus 3. What is the answer are you getting? 2 by 3. There you go. You are getting the same answer only. Did you understand this point? And what about R2? Residue at z equals to 2. What you need to do? So limit z tending to 2. Whatever the new factor that I have made, numerator as it is, differentiate the denominator 2z minus 1. In this new factor or in this new function, you just put z equals to 2. What answer you are getting? 2 minus 1, answer is 1 by 3 only. 2 minus 1 is 1 and this will be 3. 1 by 3 is the answer. Okay. You take any example. Here, why would I do this? Why would I apply this method? In this question, why would I apply this method? Will you apply this method in this question? No, because sir, you need to differentiate, sir. I will have to differentiate so much. Why would I apply this method? I will not apply this method, right? In this question, I would have applied this method. What I would do? Sir, I need to make a new function which is numerator as it is, differentiate the denominator and simply put z equals to 1 here. Why is that so? Because you are calculating the residue at z equals to 1. So simply put z equals to 1 here. What answer you are getting? 3 only. Are we getting the same answer? Absolutely. Is that clear to you? So method 2 also you will remember. Very simple method. Shall I write it down as a summary? So what is your method 2? That's our f of z will be given as numerator by denominator. Okay. Z equals to z1 or z equals to za. Z equals to za is your singular, or I should say simple pole singularity. Only it will work for simple pole singularity only. Only this method is valid only for simple pole singularity. Only for simple pole singularity. Highlight it. If you are making your own notes, then please highlight it. It will work only for simple pole singularity. Not for multiple pole. Only for single pole. Understandable? So what you will do is that you will make a new function phi z where numerator as it is and differentiate the denominator. Now someone may have a doubt that sir, how you are defining what is numerator, what is denominator? What I mean to say is that someone would say that sir, this was the function, no, z minus 1 upon z square minus z minus 2. So sir, now this is my numerator and this is my denominator. But sir, what if I write down the same function as 1 upon z square minus z minus 2 and this z minus 1 comes downward? So sir, this will become my numerator and this will become my denominator. So yes, you can treat it like that. You can also treat in this manner. Just make sure one thing, that your singularity will always be in the denominator, which is pretty obvious as well. Why it is obvious? Because if the singularity is in the denominator, then only it is the singularity. No, like basically why your z equals to 1 is a singularity, why z equals to minus 1 is a singularity, why z equals to 2 is a singularity, because they are in the denominator. That's why they are the singularity. So singularity will be surely in the denominator only. Now sir, this z minus 1, if it comes downward, will it create any problem? No. What you do? Keep this one as it is and then differentiate this part. Why would you differentiate this part? It will become very complex, no? What will be the differentiation of this part? This will be z minus 1 whole square, then z minus 1 into differentiation of this one will be 2z minus 1 minus z, then z square minus z minus 2 remains as it is and differentiation of this z minus 1 will be 1. So this is the part you will end up creating. You will here also you will get the same answer only. Here also you will get the same answer only. Whatever the answer that you got previously, here also you will get the same answer only. You put z equals to minus 1 here. In this expression, you put z equals to minus 1. In the whole expression, you put z equals to minus 1. You will get the same value of residue. What will be the value? Z equals to minus 1 you put. So this will become minus 2. If I put z equals to minus 1 here, what it will become? Minus 3. If I put z equals to minus 1 here, this will become 0. If I put z equals to minus 1 here, it will become 4. So what is the answer? 4 by 6. This 4 goes upward. 4 by 6. That means it is again 2 by 3 only. Yes, I will get the same answer. Okay, so any function you can take as numerator, any function you can take as denominator. Just make sure one thing, that your singularities will be in that denominator only, which is pretty obvious. So don't feel that sir, what will be numerator, what will be denominator. when you see the function, no, you will be able to understand that what is your numerator, what is your denominator. If my function was written in this way, then what I would have done? I would have taken z minus 1 upside. I would simply say one thing, that why would I differentiate in this manner? This differentiation is complex, but this differentiation was very easy. Differentiation 2z minus 1, that was very easy. 2z minus 1, this was very easy. Understandable? So anything can be treated as numerator and denominator. Understandable? Yeah, so what is our method? Once you make this particular function, what you will do? You need to find out residue at z equals to a. So what will be your residue at z equals to a? That will be nothing but, or residue at z equals to a will be nothing but limit, problem is there at z tending to a, phi z. That's it. This will be your answer. This will be your residue. This will be your answer. Understandable? This method will be very helpful. But if they have already given the factors, no, in that manner, if they have already given the factors, I will not apply this method. But if they have given the function like this, then in a quicker manner I can find it out. Sir, I will make phi of z minus 1 upon 2z minus 1. Now I know the problems. Problems are at minus 1 and 2. Simply put the values, get the answer. This method will be very easy for me. Understandable? Okay. So both of the methods are helpful. Some questions will be solved only by method 2. Some questions will be solved only by method 2. Method 1 will not work there. Okay. What kind of questions? This kind of question. F of z equals to tan z. You need to find out all the singularities which are lying inside the circle. Mod of z equals to 5. Also find out the sum of all the singularities. First of all, can you make the circle mod of z equals to 5? Absolutely, sir. Mod of z equals to 5, sir, it is not a problem for me. It is simply a circle with the center at 0, 0 and a radius of 5. Center at 0, 0 and a radius of 5. So this point will become x equals to 0. Sorry, x equals to 5, y equals to 0. And this point will become minus 5, 0. This point will become minus 5, 0 and so on. Now f of z is nothing but, sir, tan z, which is sin z by cos z. Where you will have the problem? You will have the problem when your cos z is 0. And when your cos z is 0, sir, cos z will be 0 at z equals to plus minus pi by 2, z equals to plus minus 3 pi by 2, z equals to plus minus 5 pi by 2, z equals to plus minus 7 pi by 2 and so on. Okay. Now you let me know what is the value of plus minus pi by 2. So that will be nothing but 1.57. What is the value of plus minus 3 pi by 2? 1.57 into 3, right? 1 pi by 2 into 3, which will be 4.71, plus minus 4.71, plus minus 5 pi by 2. So 5 into pi by 2, that will come out to be 7.85. Now you know that, sir, next values will be greater than 7.85 only, no? But you need to find out the residues at all those points which are lying inside the circle. That means, sir, this point plus 1.57 will lie here, minus 1.57 will lie here, plus 4.71 will lie here, minus 7.41 will lie here. But, sir, this point 7.85, this will lie here, minus 7.85 will lie here, and rest other points as well, they will be lying outside. So I don't need to care about those points. I only need to care about these 4 points. That means I need to find out the residue at these points only. Minus 3 pi by 2, minus pi by 2, plus pi by 2 and 3 pi by 2. Say yes or no. This diagram was required? No, sir, this diagram was not required. I could have simply put these points here. And then I would know that, sir, if mod of z is greater than 5, I am getting, that means it is outside. If mod of z less than 5, I am getting, that means it is inside. Basically, what is the mod here? 1.57. What is the value of z? Pi by 2 you put here. So pi by 2 is greater than 5? No, it is less than 5. That means it is lying inside. 3 pi by 2 less than 5 lying inside. 5 pi by 2 greater than 5 lying outside. So all these things we have already studied, right? How to find out a point which is lying inside the circle or outside the circle. So simply in the equation you put the value and then you see whether it is greater than the radius or less than the radius. If it is less than the radius, that means it is inside. If it is greater than the radius, that means it is outside. So we are supposed to find out the residues at these points. These are our matter of concern. Let me know, are they single pole? First of all, let me know, is it essential singularity or simple pole or multiple pole? What kind of singularity it is? It is Simple pole singularity. Why is that so? Are the poles being repeated? No. Pi by 2 came only once. Minus pi by 2 came only once. 3 pi by 2 came only once. Minus 3 pi by 2 came only once only. So are these singularities being repeated? No. How did you find out the singularity? By putting the denominator equals to 0. What does that mean? That means, sir, these poles are not being repeated, and I find out those poles, I find out these singularities by putting the denominator equals to 0. That means, sir, it is simple pole singularity. Simple pole singularity. So what does our method say? Our method tell one thing, that, sir, if I need to find out a residue at z equals to minus 3 pi by 2, then it would be nothing but r1 equals to limit z tending to minus 3 pi by 2. In place of z minus 3 pi by 2, this goes this side, so what you will get? Z plus 3 pi by 2 f of z. So limit z tending to minus 3 pi by 2 z plus 3 pi by 2. I hope you are able to understand what we need to do. This is the first thing that we studied here, no? The simple thing, that z minus 1 is a problem, z equals to 1 is a problem, so z minus 1, this factor I have made, multiply with f of z. So similar thing, sir, who is the problem? Sir, the problem is z equals to minus 3 pi by 2, because I am finding the residue at z equals to minus 3 pi by 2. So z plus 3 pi by 2, a factor I have made, which I will multiply with f of z. So z plus 3 pi by 2, I am multiplying with f of z, and this is the limit that I am supposed to find out. So if you put minus 3 pi by 2 here, it will become 0 into infinity, right? What is the value of tan minus 3 pi by 2? So that would be surely infinity, because here you put sin 3 pi by 2 will give you some value, cos 3 pi by 2 will give you infinity. So this will become a form of 0 into infinity. So you will have to apply L'Hopital rule. What you will do is that you will take this factor downward, you will make it an infinite by infinite form, and then you will apply the L'Hopital rule and you will get the answer. Lengthy process. You can surely get the answer, but lengthy process, because it is 0 into infinity form. What I will do, I will convert it into 0 by 0 form. How will I convert? That I will take this factor downward. What I will do is that I will solve it in this manner. Arey bhai, I will have to add a page. I will solve it in this manner. What we are finding, residue at so r1 will be the limit z tending to minus 3 pi by 2. That would be, sir, tan z divided by 1 by z plus 3 pi by 2. Z plus 3 pi by 2. Now it will become this is your infinity, because at minus 3 pi by 2 you will get infinity, and this is also infinity only. So it has become infinite by infinite form. You can apply L'Hopital rule. So limit z tending to minus 3 pi by 2, upper one, differentiation of upper one, sec square 3 pi by 2. Again it will become indeterminate form only. Okay. Divided by, you do the differentiation of this part, that will become minus 1 upon z plus 3 pi by 2 whole square. Again you are not solving any problem here. Again it is becoming indeterminate form, right? So basically here only what I will do, all these things I will not write down, because I am getting to know that it is becoming a lengthy process. So what I am saying, lengthy process. Okay, but we have some method. What we need to do, residue at method 2 we have. What is our method 2? Sir, our problems are at minus 3 pi by 2, minus pi by 2, pi by 2, and 3 pi by 2. First I am finding the residue at z equals to minus 3 pi by 2. So sir, no matter wherever you find out your residue, what is your f of z? Sir, f of z was nothing but sin z by cos z. Now you are making a new function which is phi z. What this new function will say? Sir, numerator as it is. And are they simple pole? Yes sir, they are simple pole. That's why I am able to find out the phi z. If they were not simple pole, I cannot find out phi z. So if they are simple pole, I can find out phi z. Numerator as it is, differentiation of a denominator. Numerator as it is, differentiation of denominator. What I will get? Minus sin z. Right? What is the differentiation of cos z? That is minus sin z. What is the answer you are getting? Minus 1. So your phi z is coming out to be minus 1. Now what you need to do? You need to find out the residue at z equals to minus 3 pi by 2. So what will be your residue? So residue will be limit z tending to minus 3 pi by 2 phi of z. So that would be limit z tending to minus 3 pi by 2 phi z is equivalent to minus 1 only. Now here there is no function of z, that means answer will be minus 1. Say yes or no. What will be the answer? Answer will be, answer will be minus 1. Did you understand this point? Second, residue at z equals to minus pi by 2. So what will be your R2? R2 will be nothing but, sir, limit z tending to minus pi by 2. I hope you remember this method. What was the scenario? Numerator as it is, differentiate the denominator, and then in phi of z you need to put z tending to a. So in phi of z, whatever the phi of z I am getting, that is minus 1. I am putting z tending to minus 1. What is the answer? Minus 1 only. So R1 value is minus 1, R2 value is minus 1. Similarly, you know that residue at z equals to plus pi by 2 as well, you will get the same answer. Say yes or no. That would be nothing but R3, limit z tending to plus pi by 2. What is the value of phi of z? That is minus 1 only. What is the answer? Minus 1. Fourth, residue at z equals to 3 pi by 2. R4, what is that? Limit z tending to 3 pi by 2 phi of z is minus 1. What is the answer? Minus 1. So we are having 4 residues, R1, R2, R3, R4. What we are supposed to find out? We are supposed to find out the sum of all the residues of all the singularities. So we are supposed to find out sum of residues. Sum of residues. So what is the sum of residues? So that is nothing but minus 1 plus minus 1 plus minus 1 plus minus 1. Answer is minus 4. You ask this question to the GATE aspirants, 90% of the students who have studied this topic, they will not be able to solve this question. These are not very straightforward. People find these kind of questions very tough because only they remember this method. Sir, residue is very simple, sir. I will simply cancel out and put the values. What if this kind of question is coming? You multiply z plus 3 by 2, then you see, try finding this limit. It is very difficult, no? And if you are just smart enough, what you will do? So z plus, sir, one thing I know, I have another method. If f of z is given, I can find out phi of z. Numerator as it is, differentiate the denominator. What is the answer you are getting? You are getting some phi of z. It could be a function of z. It might not be a function of z. If it is not coming out to a function of z, you are very happy. That means at all the points, at all the singularities, the residue will always be same. That is minus 1 only. And if it was a function of z, then in place of z, you would have put minus 3 pi by 2, minus pi by 2, plus pi by 2, 3 pi by 2. What answer you will be getting? Some answer you will be getting the way we have done in this question. Because phi of z was coming out to be a function of z. This was a function of z. So I put z equals to minus 1, I put z equals to 2, I was getting the answer 2 by 3, 1 by 3. Understandable? So a very good question. Try solving this question on your own. F of z is 1 by cos 2z. Try solving it on your own. You need to find out the sum of all the residues lying inside this circle. That means it is the circle of radius 2. Circle of radius 2. Very simple. In a very easy manner, sir, I can draw the circle. Circle of radius 2. So this point will be 2, 0. And this point will be minus 2, 0. So what is your f of z? F of z is 1 by cos 2z. Okay, what we need to do? We need to put a denominator equals to 0. If I put denominator equals to 0, what I am getting? The problem is there at 2z equals to plus minus pi by 2, plus minus 3 pi by 2, plus minus 5 pi by 2, and so on. So z equals to plus minus pi by 4, plus minus 3 pi by 4, plus minus 5 pi by 4, and so on. So what is the value of z you are getting, sir? What is the value of pi by 4? Pi by 4 is plus minus 0.78. What is the value of 3 pi by 4? So that is plus minus 2.35. So these points are going outside. This point is going outside. That means only this point will be accepted. Rest all the points will be going outside only, no? Because you need the values of z which are less than mod of z less than equals to 2. This is what you want. Inside the circle, no? Find the sum of all the residues inside the circle. That means this is something that you want. Mod of z less than 2. This point will be lying inside the circle. This point 2.35 lying outside the circle. So all these points will not be acceptable. Only this point will be acceptable. That means you need to find out the residue at plus pi by 4 and minus pi by 4. Understandable? Let me recheck the value of 3 pi by 4. 3 into pi divided by 4. Yes. So only we need to find out residue at z equals to pi by 4 and minus pi by 4 at these two i's. Okay. Are they simple pole? How did we find out the singularities? By putting denominator equals to 0. That means, sir, surely they are poles. By putting the denominator equals to 0, you are finding the singularity. That means surely, sir, they are pole. Now it is a single pole, or it is a multiple pole, or it is a removable pole. So that I will tell. How I will tell? That I will tell by looking at the poles. Pi by 4 is appearing only once. Minus pi by 4 is also appearing only once. What does that mean? It is a simple pole. So, sir, since it is a simple pole, what I can do? Sir, I can make a new function phi of z, where numerator as it is, differentiation of a denominator, that will become minus 2 sine 2z. Numerator as it is, differentiation of a denominator. So phi of z is 1 by minus 2 sine 2z. Okay, so you need to find out the residue at z tending to pi by 4. So what you will do? Limit z tending to pi by 4, and in phi of z you will put the value minus 1 by 2 sine 2z. Sine 2z. So if you put pi by 4 here, so sine pi by 2 will be 1 only. So answer is minus 1 by 2. What will be the value of R2? Value of R2 would be limit z tending to minus pi by 4 minus 1 by 2 sine 2z. So what you will be getting? Sine minus pi by 2. So answer would be, what is the value of sine minus pi by 2? That is minus 1. So answer would be 1 by 2. So these are two residues we are getting, minus 1 by 2 and plus 1 by 2. What is the summation? Summation is 0. This question you should have been able to do on your own. Okay, summation is coming out to be 0. Although minus 1 by 2 and plus 1 by 2 we are getting. How you should be able to do on your own? Sir, very simple. What I need to do is that numerator as it is, differentiation of denominator. So minus 2 sine 2z. Sir, my points are plus pi by 4 and minus pi by 4. Or you can simply think that, sir, wherever cosinusoid is 0, my sinusoid would be 1 or minus 1, right? Where cosinusoid is 0, then sinusoid would be either 1 or minus 1, because sin square theta plus cos square theta is 1. So either it will be 1 or minus 1. So at one point it is coming out to be 1, and other point it is coming out to be minus 1. That means they will cancel out each other. Summation of R is 0. Okay, well and good. Let's go to the next question. Sum of residues of f of z equals to 1 upon e to the power z minus 1 inside the region mod of z equals to 7. It is a very good question. Try it on your own. Don't mess it up. It is actually a very good question. You will do one error here. Try doing it on your own. Pause the video. Try doing it on your own. You will mess it up. I am telling you. So what is your f of z? If you did not mess it up, then congratulations. You are doing something good. But there are higher chances that you will mess it up. So what is your region? Region is, sir, circle with the center 0, 0 and radius of 7. So what I can do is that I can simply copy it again. Center 7, 0. Right? What is your f of z? Sir, f of z is 1 upon a to the power z minus 1. Where will be the poles? Sir, the problem will be in the denominator. If I put e to the power z minus 1 equals to 0, sir, value of z I am getting is ln 1, and ln 1 is 0 only. So from here I am getting z equals to 0. So sir, my pole will be at z equals to 0 only. That means, sir, here will be my pole. Is it a simple pole? Yes. So z equals to 0 will be my pole. Is that correct? No, there will be poles at other points as well. What all are those other points? Z is a complex variable, no? Z is the complex variable. How will you solve this equation? This solution is wrong. Z equals to 0 is surely one of the answer. That is pretty sure. What will be the exact solution? Sir, e to the power z minus 1 equals to 0. E to the power z equals to 1. But sir, exponential is periodic with iota 2 and pi, no? Say yes or no? E to the power iota 2 and pi. What is e to the power iota 2 and pi? So that is equals to 1. So if there is exponential, in exponential to the power z is given, no, then you have to be aware, because you know that, sir, e to the power iota 2 and pi is 1 only. So here you have to be aware. So what you are getting, z plus iota 2 and pi, z plus iota 2 and pi is coming out to be 0. That means z is coming out to be minus iota 2 and pi. So from here, what is n? N is some integer value. So from here, what is the value? What all values of z you are getting? So value of z would be, I can put n equals to 3, then what I will get? Minus iota 6 pi if I put n equals to 2, minus iota 4 pi if I put n equals to 1, minus iota 2 pi if I put n equals to 0, 0 if I put n equals to 1, iota 2 pi, iota 4 pi, iota 6 pi, and so on. In that manner, these all values I will be getting. Now let me know which will be lying inside the circle and which all points will be lying outside the circle. Inside the circle, what is the value of 2 pi? That is 6.28, right? What is the value of 4 pi? That will be 12.56, and so on, in that manner. This is 0 only. This will be minus 6.28, minus iota 6.28, sorry. This is iota, this is iota. This is minus iota 6.28. This is minus iota 12.56, and so on, and so on. So 0 will be lying here. What is iota 6.28? What is this point? So this point is 0,7. Iota 6.28 will be lying here, no? Iota 12.56 will be lying outside. Iota minus 6.28 will be lying here. Like basically mode of z equals to 7. Mode of z equals to 7. So if mode of z less than 7, then all the points will be lying inside. So this point will be lying inside, this point will be lying inside, this point will be lying inside, this point would be outside, this point would be outside. So which all points are lying inside? Sir, z equals to 0 plus iota 2 pi and minus iota 2 pi. Sir, these 3 points are lying inside. But sir, here I was taking only 1 point. This would have created the problem. Are you able to understand this point? Here I was taking only 1 point, which was z equals to 0. But sir, z equals to iota 2 pi, z equals to minus iota 2 pi, they are also lying inside the circle. Is that understandable to you or not? 3 points I need to take. Are they simple pole? Absolutely. Why they are simple pole? Because sir, I got the answer by putting the denominator equals to 0, plus they are different as well. That means, yes, they are simple pole only. For the simple pole, what I can do? Sir, I can make a function phi of z, which is numerator as it is, differentiation of the denominator. Differentiation of the denominator will give you e to the power z. Now what I need to do is that I just need to do limit z tending to your singularity. Singularity, whichever it is 0, iota 2 pi minus iota 2 pi. So limit z tending to singularity phi of z. This is what I need to find out. So can I find out the value of R1, R2 and R3? Absolutely. How will I find out the value of R1, R2, R3? So this is how I will find out the value of R1, R2, R3. R1 will be limit z tending to 0 phi of z. What is phi of z? 1 by e to the power z. If you put z tending to 0 here, e to the power 0 is 1. Answer is 1. What is R2? Limit z tending to iota 2 pi. F of z is 1 by e to the power z. So 1 by e to the power iota 2 pi. What you are getting? What is e to the power iota 2 pi? That is also 1 only. Z equals to 0, I put e to the power 0 is 1, e to the power iota 2 pi is also 1. E to the power iota 2 pi, that means making an angle of 2 pi. Here you will be reaching, no, magnitude 1 making an angle of 2 pi. It would be 1 only. Similarly, your R3 will also be 1 only. Because what is z tending to minus iota 2 pi, that means what is e to the power minus iota 2 pi? E to the power minus iota 2 pi. Magnitude 1 making an angle of minus 2 pi. So again you are reaching at 1 only. Right? So what is R3? R3 is limit z tending to minus iota 2 pi 1 by e to the power z. So in place of z, what you will put? In place of z, I will put minus iota 2 pi. So what is the answer you are getting? 1. So 1, 1, 1. These 3 answers we are getting. 1, 1, 1. So 3 residues we are having. That means what will be your summation R? That would be 1 plus 1 plus 1. Answer is 3. Are you able to understand this point or not? A very, very good question, a very important question. Answer is 3, but a lot of people would have told the answer as 1. That answer would have been wrong. So whenever exponential to the power z is coming, no, always be aware that something you can miss. because exponential is periodic with iota 2 pi. If it is periodic with iota 2 pi, that means you need to take all the points, see the circle, you got to know that inside the circle, sir, there are 2 more points available. Understandable? Okay, let's go to the next question. Let's see this question. Sum of the residues, I guess this is the last, right? Yes. So let's see this question, then I will take a break. So sum of the residues of f of z equals to 1 by sine hyperbolic z inside the circle mod of z equals to 4. Sine hyperbolic z. What is sine hyperbolic z? So sine hyperbolic z is nothing but e to the power z minus e to the power minus z divided by 2. So in the examination, whenever you see no hyperbolic function or cos hyperbolic, sine hyperbolic, then what you do is that you deal in this way. Forget about your hyperbolic or anything. You solve your question in this way now. That means in the examination, what I would have done is that I would have changed my question in this way. I would have changed it like this. This is how I would have changed it. Now, sir, what I need to do? I need to find out that singularity. Where will be the singularity? Singularity would be, sir, at this point. Equals to 0. That means e to the power z equals to e to the power minus z. That means, sir, z has to be equals to 0 only. Is that correct? No. Why is that so? Other points will also be possible, no? Because z is periodic with, exponential is periodic with iota 2 pi. That means in place of z, what I can put? Iota 2n pi. Right? In place of z, I can put iota 2n pi. Would be equals to e to the power minus z. Now, someone would say that, sir, why you are not putting iota 2 pi here? Why you are not putting iota 2n pi here? You should put iota 2n pi here as well. If I have put here n, then here I will have to use m. Basically, if I have put n here, so here I will have to use another variable m. So eventually what answer you will be getting? Z equals to iota 2n pi would be equals to minus z minus iota 2m pi. So this will become here. So you will get 2z equals to iota, minus sign you can take outside, although minus sign will not matter, minus iota 2n pi plus 2m pi. So 2 and 2 will get cancelled out. Eventually you are getting minus n pi minus m pi. So you can take minus iota pi common, n plus m. So this is also another integer only. N was integer, m was integer. Now n plus m you are getting. This is also another integer only, no? So doesn't matter. That means you don't need to introduce it again. So in place of writing e to the power z plus iota 2n pi, and here I will write e to the power minus z iota 2 plus 2m pi. That 2m pi I will not even write. I know that, sir, this guy is also periodic and this guy is also periodic, but only at one place I will write down iota 2n pi, not at both of the places, because eventually I know that, sir, this will also come out to be an integer only. Are you able to understand this point? So here only at one place I will write down in this way. And now I need to compare. So this particular thing will be compared with this. So z plus iota 2n pi will come out to be minus 2z. So 2z is coming out to be minus iota 2n pi. So z is coming out to be minus iota n pi. Minus iota n pi. This is the value of z you are getting. What is your circle? This is my circle. Radius of 4, right? Radius of 4. 0, 4, 0, minus 4, right? So where all are the values of z? You put the value of n equals to 2. Put the value of n equals to 3, whatever you want to put. So if I put the value of n equals to 2, what I will be getting? Minus iota 2 pi. Then minus iota pi. Then put n equals to 0. Then iota pi, iota 2 pi, and so on. What is this? This is 0 only. What is this? This is iota 3.14. What is this? This is iota 6.28. What is this? This is iota minus 3.14. This is minus iota 6.28. Now, sir, mod of z equals to 4. This will give mod of z less than 4. This will give mod of z less than 4. This will also give mod of z less than 4. This will not give mod of z less than 4. This will also not give mod of z less than 4. That means all 3 points will be acceptable. So what all points will be acceptable? So z equals to minus iota pi, 0, and plus iota pi. Are they simple pole? Are all of them simple pole? Absolutely, sir. They are all simple poles. If they are simple pole, what I need to do? If they are simple poles, sir, I need to introduce another function phi of z. What that would be? Numerator as it is, numerator as it is, differentiation of denominator. Numerator as it is, differentiation of denominator. What is my denominator? So denominator is e to the power z minus e to the power minus z. So differentiation of e to the power z would be e to the power z only, and differentiation of e to the power minus z would be minus e to the power minus z. So this is the answer you will be getting, although it is cos hyperbolic z only, right? It is cos hyperbolic z only, because what is the differentiation of sine hyperbolic z? That will be cos hyperbolic z. So you are getting the same answer actually. But I have said one thing, that in the examination, whenever hyperbolic function is coming, you will do your calculation in exponential term, not in the hyperbolic term. So this is just to make you feel that okay, something different we are asking, but nothing different we are asking. We are asking the same thing only. Understandable? So 0, iota pi and minus iota pi, these are the points we are supposed to put. Understandable? So now we are supposed to put z equals to 0. So a residue at z equals to 0. So R1 would be limit z tending to 0. Put z tending to 0 here. So this will become e to the power 0, 1, 1, 2 by 2. Answer is 1. Then I need to put z equals to iota pi. Limit z tending to iota pi to e to the power iota pi. What it will give you? E to the power iota pi. This will give you minus 1, right? It will give you minus 1, and this will also give you minus 1. Answer is minus 1. And what about z equals to minus iota pi? So this was your R2, R3. So limit z tending to minus iota pi, 2 divided by, if you put minus iota pi, it will give you the same result. Answer is minus 1. E to the power iota pi, I hope you know that is 1 only. And what is e to the power minus iota pi? Making an angle of minus pi. What will be the answer? Minus 1 only. So e to the power minus iota pi is also minus 1. And sorry, this is also minus 1. Sorry guys. E to the power iota pi is minus 1. E to the power 0 is 1. E to the power iota 2 pi is 1. Right? E to the power iota pi is minus 1. E to the power minus iota pi is minus 1. What is e to the power iota pi by 2? So that is equals to iota. And what is e to the power minus iota pi by 2? So that is equals to minus iota. All these things I hope you remember, right? So yeah, this is what we are supposed to find out. Now if you need to do the summation, so what is the answer? 1 minus 1 minus 1. So answer is minus 1. Okay, so here the answer will be minus 1. So this was the question. So this is how you are supposed to solve. Is that understandable to you? Okay, so I know a lot of people would have matched up these kind of problems. These are not very straightforward. As of now, you might feel like that, yes sir, I will be able to solve in the examination all, but these kind of questions, hardly 1 or 2% students will be able to solve. Only those students who have studied complex analysis, out of those students, hardly 1 or 2% students will be able to solve these kind of questions. Although they will not ask this question, sum of residues. What they would ask? They would ask the complex integration. This is something they would ask. So answer would be 2 pi I and the sum of residues. What is the sum of residue? Answer will be 2 pi I multiply with sum of residue, which is minus 1. So answer will be minus 2 pi I. So this is something they would ask, which we will see in the next lecture. But as of now, we are learning about residues, because residues are very important to solve the complex integration. Okay, to solve the complex integration, residues are very important. So that we are studying as of now. So this is how we are going to solve. Okay, this question you should have been able to solve on your own if you have seen the solution of previous question. So this should have been solved on your own only. Yes, sir. What I would do is that I have got the answer, numerator as it is, differentiation of denominator, so I can do, and then I need to put the values. I got the answer 1 minus 1 minus 1, answer is minus 1. Understandable? Okay then. So let's now we will understand about removable singularity. For removable singularity, what is the method? So method is same method as simple pole. Same method is there. Okay, but here there will be an interesting result. What will be the interesting result? That we will see. So this you already know that sir, at z equals to 2 I will get the singularity, but sir, that would be removable singularity, right? Removable singularity. Why it is removable singularity? Because sir, I know that if I find limit z tending to 2 f of z, sir, I get the finite answer. Right? I get a finite answer. That means it is removable singularity. Removable singularity. Now the same method is there, no? What you are supposed to find out? You are supposed to find out at z equals to 2. So what you will do? What you will do is that you will find out a residue at z equals to 2. So sir, my way would be residue at z equals to 2 would be nothing but limit z tending to 2. At z equals to 2, I am supposed to find out who is creating the problem, z minus 2 f of z. Limit z tending to 2, z minus 2, f of z is sin z minus 2 upon z minus 2 upon z minus 2. This and this is getting cancelled out. If you put z equals to 2 here, what you will get? Sin 2 minus 2, that would be equals to sin 0. So answer will be 0. So what is the residue you are getting? The residue that I am getting is 0. So residue is 0. Same for this one. Solve this question as well. Now sir, here there are two problem points. Two guys are creating the problem. Z plus 2 and Z minus 2 here. So two guys are creating the problems. Who are two guys? Sir, if you put the denominator equals to 0, I can see that sir, Z equals to 2 and Z equals to minus 2 will create the problem. But one of them is a removable singularity. Which guy is removable? You know that sir, this and this can get cancelled out. So sir, Z equals to 2 is the removable guy. This is your removable, and this is your simple pole. Say yes or no. Both are having the same method. So first I will find out for simple pole. So for simple pole, what will be my singularity? Sorry, what will be my residue? So residue would be, sir, limit z tending to minus 2, z tending to minus 2, z plus 2 f of z. So what is the answer you are getting? Z plus 2 f of z. So limit z tending to minus 2, z tending to minus 2, z plus 2 you will remove. So what you will get? Z minus 2 upon z minus 2. What is the answer? Answer is 1. This is the residue you are getting. And residue at z equals to plus 2. Residue at z equals to plus 2. So z minus 2 f of z, limit z tending to 2, z minus 2 upon, what I am doing is that I am multiplying z minus 2 with f of z. So z minus 2 into z minus 2 upon z plus 2 upon z minus 2. So this and this is getting cancelled out. If you put 2 here, what answer you will be getting? 2 minus 2 will be 0 divided by 4. What is the answer you are getting? 0 only. So your residue at, only I am talking about removable singularity. Residue at removable singularity. Singularity is coming out to be what? Here also there was z equals to minus 2 was removable singularity. It is coming out to be 0. Here also it is coming out to be 0 only. So what is the answer? Removable, at the removable singularity, residue will always be 0. So that's the line you need to remember. If there is a removable singularity, then simply you can cancel it out. That's it. Basically, you can make your function f of z as 1 upon z plus 2. So if my function is like, how I would have solved this question in the examination hall. Let's just say they are asking me the sum of residues. This is the question they are asking. So I would see that, sir, my function f of z is actually coming out to be, so z minus 2 and z minus 2 will get cancelled out of 1 upon z plus 2. So that's it. What I would tell, so z equals to minus 2 will be my singularity. It is simple pole singularity. And can I find out the residue? Yes sir, residue would be nothing but z plus 2 is creating the problem, remove that, and limit z tending to minus 2 you put, and z plus 2 is creating the problem, so remove that. What is the answer? Answer is 1. So your sum of residue will be simply 1 only. Sir, here there was another singular point. Absolutely there was another singular point. Sir, the another singular point was z equals to 2 as well. But sir, that was removable, and I know that, sir, residue for the removable singularity will be 0 only. I don't need to consider them. So a very simple point from this 2 slides of discussion, only thing you need to remember is that for a removable singularity, the sum of the residue will be 0. That's it, nothing more. Sum of the residue will be 0. That means for a removable singularity, the residue will be 0. Sum of residue will be depend on that what kind of singularities you are having. If simple pole is there, then you will have to find out for simple pole. But for the removable pole, you don't need to find out this residue. You already know that, sir, residue for the removable singularity will come out to be 0 only. For the removable singularity, residue will be 0. Is that clear or not? Completely clear, sir. So for the simple pole, we have seen the method. Just revise this method again for the simple pole. We started from here. For simple pole, we have got one method. That was, sir, whoever is creating the problem, remove that, put the value. But we developed a method 2 as well. What was the method? Numerator as it is, differentiate the denominator. Now in this function, you put the values of your singular points. And then we saw questions. Tan z, sin z by cos z, always it will be -1. Then we saw this question, 1 by cos 2z. Here we got different answers. Then we saw this question. Here you will be messing up that only z equals to 0 is the answer. But actually, z equals to 0, iota 2 pi minus iota 2 pi are the answers. Similar goes here as well. Here also people would think that only z equals to 0 is the answer. But z equals to 0, iota pi and minus iota pi are the answers. Those points you need to put and you need to get the residues. Sum of residue is also important. It is coming out to be -1 here. Then for the removable singularity, sir, sum of all the residues will be sum of all the residues at the removable singularity would be 0. At only the removable singularity. That means removable singularity will not give you any residue. For the removable singularity, the residue would be 0 only. Understandable? Okay. Next we will see for multiple poles. For repeated poles or for multiple poles. This is our case 3. So that we will see after a break. You revise whatever that we have studied. Within 5 minutes you will be able to revise, and then we will see this repeated pole case. Okay. Yeah. Thank you. Okay then. Yeah, welcome back. So we have been studying about residues. Now we need to study the residues for repeated poles. So can you see this function f of z equals to e to the power 2z upon z minus 1 whole square? Where will be the singularities? So singularities would be when your z minus 1 whole square equals to 0. So sir, I will get the singularity at z equals to 1 and z equals to 1. What does that mean? That means, sir, z equals to 1 is a repeated pole. It is a pole, sir, but it is a repeated pole. It is a repeated pole. Say yes or no. So for repeated pole, there is a certain method. What is that method? Let me write it down here. You don't need to remember the method, you just need to remember the way. Basically, you don't need to remember the formula. Here I will write down the formula, but this is something that you are not supposed to remember. So your z equals to z naught is your repeated pole. Repeated pole of order n. Of order n. This is your repeated pole of order. Z equals to 1 is your repeated pole of order 2, right? Z equals to 1 is your repeated pole of order 2 because it is occurring twice, right? So it is repeated pole of order 2. Order 2. So what you need to do? You need to multiply z minus z naught to the power n with f of z. This is what you will do. Basically, what I mean to do is that I will nullify this. Who is creating the problem? Sir, z equals to 1 is creating the problem. That means, sir, this factor is creating the problem. So just nullify it. So what you will do? The same process that we were doing, z minus 1 whole square multiply with f of z. That means e to the power 2z upon z minus 1 whole square. So what does that mean? This and this will get cancelled out. It will be gone. Then you will have to differentiate it. Then you will have to differentiate it. What you will do? You will do the differentiation. You will do the differentiation. When we were studying simple pole, so here, what was the power? When we were studying simple pole, so what we were doing here? Sir, we were multiplying with z minus 1, right? So what was the power here? Power was 1. Did you differentiate it? No, I did not differentiate it. Or I can say I differentiated 0 times. When the power was 1, I differentiated 0 times. When the power is 2, you will differentiate 1 time. When the power is 3, you will differentiate 2 times. That means when the power is n, so I will differentiate with n minus 1 times. Now it is the pole of order 2. So power is 2 here. So I will differentiate 1 times. And as much time as you have differentiated, you will divide by that factorial. I have differentiated 1 times. Here there is power 2. So I have differentiated 1 time. So I will divide by 1 factorial. And after that, what you will do? Limit z tending to this pole. Limit z tending to z naught. So limit z tending to 1. It is very simple process. This is your residue at repeated pole z equals to 1. A very simple process. As of now you might feel like that, sir, what this is, but if you look closely it is nothing. If you look closely it is nothing. What I will do in the examination hall, I would see, okay sir, z equals to 1 is my repeated pole, so my residue will be, sir, r1 limit z tending to 1. This much will be there for sure. Then sir, this guy is creating the problem, no? So remove that guy. So if I remove that guy, what I will be left with? E to the power 2z. Now sir, this guy was coming twice, no? So I will differentiate one time. Since I have differentiated one time, so I will divide with 1 factorial. If let's just say if it was e to the power 2z upon z minus 1, what you would have done? First you would have removed it. Now this guy was coming, z equals to 1 was coming only once, so you will differentiate 0 times and then divided by 0 factorial and then limit z tending to 1. This is the process that you have done. Differentiated 0 time means no differentiation, that means it is irrelevant. What is 1 by 0 factorial? That is also 1, irrelevant. Limit z tending to 1 e to the power 2z. This is what you have done previously when you were solving for single pole, when you were solving for single pole or simple pole. When you were solving for simple pole, you used to remove this guy. After that you used to differentiate 0 times and then divide with 0 factorial. So what did you understand? That this particular method is same. This particular method is same for the repeated pole as well, and it is working for the simple pole as well. But why we studied separately? Because there you don't need to think about differentiation and all those things. There simply whoever is creating the problem, remove that, put limit z tending to 1. That's it. Here whoever is creating the problem, remove that, but you have to differentiate as well and divide with the factorial as well. So you need to differentiate 1 times. Since there is power 2, you need to differentiate 1 times and then divide with 1 factorial. Job done. Understandable? Limit z tending to 1. What is 1 factorial? 1 factorial is 1 only. D by dz of e to the power 2z. D by dz of e to the power 2z would be e to the power 2z multiply with 2. So you put z equals to 1 here. What answer you will be getting? 2 e to the power 2. That's the answer. This is the answer you will be getting. This is your residue. 2 e to the power 2 would be your residue. This is the answer. Did you understand this point or not? E to the power 2z was there, you need to differentiate it 1 times. So 2 will come in front, 2 e to the power 2z, then you put z tending to 1, z tending to 1, you put here 2 e to the power 2. 2e square is your answer. Understandable? Let's see next question. What is the problem? So z equals to minus 2 is the problem. Z equals to minus 2 is the problem, which is occurring, sir, 3 times. It is occurring 3 times. What I will do? What is my process? You need to find out the residue. Residue at z equals to minus 2. What you will do? Sir, R residue I am supposed to find out. Limit z tending to minus 2. Whoever is creating the problem, remove that. Whoever is creating the problem, remove that. What you will get? Cos z. Sir, it was occurring 3 times. I will differentiate 2 times. And then, sir, divided by 2 factorial. There you go. This is the answer. Okay. As much time as you are differentiating, you need to divide that as well. I am pretty sure you will forget this thing. In the examination, a lot of people will forget this thing. Okay. So, what answer you are getting? Sir, 1 by limit z tending to minus 2, 1 by 2. Differentiation of cosinusoid will be minus sin z, and then differentiation will be again minus cos z. Again, it would be minus. Twice you need to differentiate, no? Cos z differentiation 1 times will give you minus sin z, and differentiation of minus sin z will give you minus cos z. Differentiation you need to do. I hope it is not that difficult for you. D by dz, d by dz. Okay. So it will give you minus cos z. Now you need to put z tending to minus 2 here. So what answer you will be getting? Sir, minus 1 by 2. Minus 1 by 2. Minus sign I am taking outside. Cos, in place of z you need to put minus 2. You know that, sir, cos will eat up the negative sign. So answer I will get is minus 1 by 2 cos 2. This is the answer that you are getting. Is that understandable to you? Very, very simple process. Very, very straightforward process. Next example, let's take the next example downward only. Here only, let's take the next example. I will put up the next example here. So this is the next question. This is your third question, your third example. Okay. So here, who are creating the problems? Sir, I know that z equals to 1 will create a problem, and then z equals to minus 2, minus 2 and minus 2. So it is the order of it is your multiple pole. This is your multiple pole. Multiple pole of order 3. Multiple pole, or you can say repeated pole of order 3. And this is your simple pole. So for simple pole, what is the method? For simple pole, residue at z equals to 1. Residue at z equals to 1. At z equals to 1. What that would be? So that would be R1. What he will say? He will say simply one thing. Limit z tending to 1. Whoever is the problem, remove that. This guy is the problem, no? Remove that. You are finding at z equals to 1. So when z is equals to 1, then this guy is the problem. Remove that problem. What you are left with? 1 upon z plus 2 whole cube. And now put this one here. Your answer is done. What is the answer you are getting? 1 by 3 cube. That means 27. 1 by 27. Understandable? Now next you need to find out residue at z equals to minus 2. Here the differentiation method will not work. Okay, this method will not work. Numerator as it is, differentiation of a denominator. This method will not work for repeated pole. For single pole it may work. For repeated pole it will not work. I hope you remember it. For single pole, yes, it will work, but for the repeated pole it will not work. Okay, so for the repeated pole you will ignore this method. Yeah, so residue at z equals to minus 2. What that would be? So that would be R2 equals to limit z tending to minus 2. Now sir, this guy is repeating. Whoever is the problem, this guy is the problem. So remove that guy. What you will be left with? You will be left with 1 upon z minus 1. 1 upon z minus 1. 1 upon z minus 1. But sir, this particular guy was repeated 3 times. This particular guy was repeated 3 times. So what you need to do? You need to differentiate 2 times. And then divide with 2 factorial. Is that understandable to you? Did you understand this process? Always remember this process. Okay, simply it is a process which you need to remember. This formula you don't need to remember. It is not a formula. A simple process is there. So z equals to minus 2 is creating the problem. Z equals to minus 2, this guy is creating the problem. So remove it. Once you remove it, what you are left with? 1 upon z minus 1. Now sir, there was power 3, so you differentiate 2 times. There was power 3, you differentiate 2 times. Then divide with 2 factorial. That's it. Okay. So what this will give you? 1 upon z minus 1. First time differentiation will give you minus 1 upon z minus 1 whole square, and second time differentiation will give you 2 upon z minus 1 whole cube, right? This 2 goes in front, z minus 1 whole cube. So this is the answer you will be getting. So limit z tending to minus 2, 1 by 2 factorial, multiply with 2 upon z minus 1 whole cube. I hope you know what we have done here. This is minus 1 minus sign and z minus 1 to the power minus 2. Then I differentiated it. So minus 2 will come in front. This will become minus 3 power. So 2 upon z minus 1 to the power 3. And 2 and 2 will get cancelled out. Just put minus 2 here. 2 factorial, this will get cancelled out. Just put minus 2 here. What you will be getting? Minus 2 minus 1 to the power 3. So what is the answer? Minus 1 by 27. Minus 1 by 27. And here 1 by 27. So for z equals to 1, sir, it was a simple pole. I just removed it. I put z equals to 1 here. Answer is 1 by 27. For z equals to, sir, minus 2, it is a multiple pole, sir. Since this is a multiple pole, what I need to do is that, sir, it is coming 3 times. That means first you remove this. Then whatever the factor that is left, whatever the function that is left, you differentiate it 2 times. When I differentiate 2 times, this is the answer that I am getting, and divide with 2 factorial as well. The number of times you are differentiating, divide with that factorial as well. So this is the answer that I am getting. 2 to get cancel out, put minus 2 here. Answer is minus 27. Okay, minus 1 by 27. Let's go to the next case, which is essential singularity. So you already know what is essential singularity. Sir, in this function, if I see, as of now I don't see any problem, but I know z equals to 0 could be a problem. Exponential function it is, sir. I know how to do the expansion. I already remember the expansion. 1 plus x square by 2 factorial. So first of all, let's do the expansion. Okay. So first of all, sir, I will do the expansion, which will be 1 plus 1 by z plus 1 by z square divided by 2 factorial. So can I say 1 by z square divided by 2 factorial? That means multiply with 1 by 2 factorial plus 1 by z cube divided by 3 factorial. That means multiply with 1 by 3 factorial, and so on. Now you know that, sir, z equals to 0 is a singularity. Z equals to 0 is a singularity. This you know. So what is your singularity? Z equals to 0 is your singularity. That means what you are supposed to find out? Your residue at z equals to 0, your residue at z equals to 0 will be equals to, residue at z equals to 0 will be equals to coefficient of 1 by z in f of z. Z equals to 0. If it was z equals to z naught, then what would be the scenario? Residue at z equals to z naught, then it would have been equals to coefficient of 1 upon z minus z naught, coefficient of 1 upon this z naught, you take this side, coefficient of 1 upon z minus z naught in f of z, Now in the expansion of f of z, you let me know what is the coefficient of 1 by z. What is the coefficient of 1 by z? Like 1 by z is multiplied with what? 1 by z is multiplied with 1. So what is the answer? Our residue is nothing but 1. There you go. This is the answer. Okay, very simple thing. Very straightforward, right? Similarly, sir, here as well I cannot see anything. What I will do? I will do the expansion. Sin x expansion is x plus x minus x cube by 3 factorial plus x to the power 5 by 5 factorial. So, sir, what will be the expansion? Expansion will become 1 upon z minus 2. You write down 1 upon z minus 2 minus 1 upon z minus 2 whole cube divided by 3 factorial plus 1 upon z minus 2 to the power 5 divided with 5 factorial and so on. Right? This is the scenario. Understandable? Now, where is the problem? The problem is at z equals to 2. So, z equals to 2 is the singularity. So, you are supposed to find out the residue at z equals to 2. Residue at z equals to 2. So, what will be the residue? So, that would be equals to coefficient of 1 upon z equals to 2. If you take this side, coefficient of 1 upon z minus 2 in f of z. So, what is the coefficient? Sir, 1 upon z minus 2 is multiplied with 1 only. So, what is the coefficient? That is 1. So, this is the answer. There you go. Okay. Next question. Z cube e to the power 1 by z. Sir, again, as of now, doesn't feel like there is any problem, but I know that, sir, this will become if I put z equals to 0, then it will create a problem because it will become e to the power infinity. So, let's do the expansion. Z cube 1 plus 1 by z plus 1 by z square divided with 2 factorial. The same thing I am doing, divided by 2 with 2 factorial plus 1 by z cube divided with 3 factorial plus 1 by z to the power 4 divided with 4 factorial. Multiply with 4 factorial, you can say. Multiply with 4 factorial plus 1 by z to the power 5 multiply with 5 factorial plus 1 by z to the power 6 multiply with 6 factorial, and it will keep on going. Right? So, you multiply z cube inside. So, what you will be getting? Z cube plus z square plus z divided by 2 factorial plus 1 by 3 factorial plus 1 by z multiply with 4 factorial plus 1 by z square. I am just multiplying z cube inside, nothing else. No simple mathematics, just multiplying z cube inside. What I am getting? Z to the power 2 5 factorial, right? Plus z to the 1 by z to the power 3 6 factorial and so on. This is what we are getting. Now, who is the problem from here? If you see, who is coming out to a problem? Z equals to 0 is the singularity, no? Z equals to 0 is the singularity, right? Because if you see here, if I put z equals to 0, no issue. Z equals to 0, no issue. Z equals to 0, no issue. If you put z equals to 0 here, yes, there is a issue. If you put z equals to 0 here, yes, there is a issue. And what is the power of 1 by z? That would go till infinity, no? If you extend this, it will go till infinity. So, yes, z equals to 0 is the singularity. And what kind of singularity? It is essential singularity. It is essential singularity. Essential singularity. And since it is essential singularity, what does that mean? What will be your residue? Residue will be nothing but a coefficient of 1 upon z minus 0, or you can say coefficient of 1 by z in f of z. What is the answer you are getting? Coefficient of 1 by z is coming out to be 1 by 4 factorial, which is nothing but equals to 1 by 24. 4 factorial is 24. So, that's the answer that we are getting. This is the answer that we have. Understandable? 1 by 24 is the answer. Okay, well and good. So yeah, next question, try doing it on your own. So as of now, nothing I am able to understand, but I can do the expansion. Cos of 1 by z minus 2. Do you remember the expansion of cos x? That it is 1 minus x square by 2 factorial plus x to the power 4 by 4 factorial plus minus x to the power 6 by 6 factorial, and it will keep on going. So do it. Then you will get to know who is creating the problem. So z minus 2 whole square, 1 minus z minus 2 whole square divided by 2 factorial plus z minus 2 to the power 4 divided by 4 factorial. अरे भाई, it is 1 upon z minus 2, no? So it is 1 upon z minus 2 whole square divided with 2 factorial plus 1 upon z minus 2 to the power 4 divided with the 4 factorial minus 1 upon z minus 2 to the power 6 divided with 6 factorial, and in that manner it will keep on going. So what you will be getting? Z minus 2 whole square minus 1 upon 2 factorial plus 1 by 4 factorial is there, 1 by 4 factorial, z minus 2 to the power 2 minus 1 by 6 factorial, z minus 2 to the power 4, and so on. Right? In that manner it will keep on going. Now can you tell me where is the problem? Yes sir, z equals to 2 will create a problem. Sir, here there is no issue, but here there is a issue, sir. Here also there is a issue. And also I know one thing, that sir, eventually here in the end 1 upon z minus 2 will give us infinity power, because you can see power is increasing only. 1 by z minus 2 to the power 2, z minus 2 to the power 4, eventually it will give you infinity power. So z equals to 2 is your essential singularity. It is your essential singularity. And if it is my essential singularity, then what will be my answer? What will be the answer? What will be the residue? So residue will be nothing but coefficient of 1 upon z minus 2 in f of z. What is the coefficient of 1 upon z minus 2 in f of z? Can you see this factor? It is not even there, no? 1 upon z minus 2 is not even there. That means it would have been 0 multiplied with 1 upon z minus 2. Say yes or no? So what is the coefficient? Coefficient is 0. So what is the residue? Residue is 0. That's it. This is the answer. It is not even present, no? It is not even present. 0 is not even visible. Where it is visible? Sorry, 1 upon z minus 2 is not even visible. Here can you see 1 upon z minus 2? Sir, power 2 was there, then power 0 was there. This is 1 upon z minus 2 to the power 0, right? So power 0 is there, then power 2 is there, 4 power, 6 power, 8 power, power 1 will not even be there. Here always the power 1 we are considering. Always power 1 we are considering. Coefficient of z minus z, 1 upon z minus z naught, 1 upon z minus z naught. So power 1 I need to see. Do I get the power? No. So what is the residue? 0. So what is the answer? Answer is 0 only. That's it. Okay. So this is how we are supposed to solve. This is a good question. Try it on your own. Try it on your own. Don't mess it up. Try doing it on your own. Very good question. These kind of questions till this point are not introduced in the examination. They will ask very simple. This kind of thing they will ask, or this kind of e to the power 1 by z, or sine 1 upon z minus 2. These kind of very simple expression they ask. But from now onwards, we will see some complex expression. Like this is a complex expression. So you find out where is the singularity, what kind of singularity we are having, and after that you comment about the residue. Okay, they are already saying, although it is already given that there would be essential singularity at z equals to 0. But if only this function is given, and they are not talking about the singularity, they are only asking about the residue, then what will be your residue? Or they can simply put f of z equals to sine z into cos 1 by z, find out the residue at z equals to 0. If this is the question they are asking, then what you will do? So let's check that out. Sir, f of z equals to cos z sine z multiply with cos 1 by z. Sir, as of now I don't see any singularity, nothing I am able to comment. So what we do? Expand. How will you expand sinusoid? So z minus z cube by 3 factorial plus z to the power 5 by 5 factorial minus z to the power 7 by 7 factorial and so on. And how will you expand cos 1 by z? 1 minus 1 by z whole square divided with 2 factorial plus 1 by z to the power 4 divided with 4 factorial minus 1 by z to the power 6 divided with 6 factorial and so on. Say yes or no. When you multiply both of them, although you will not do the multiplication, but from this expression you can tell that where will be the singularity from this expression only. You can see that, sir, if I put z equals to 0 here, then there is an issue. So yes, z equals to 0 will be a singularity. Z equals to 0 will be a singularity and it will be an essential singularity. Why is that so? Because, sir, I know that here z to the power infinity I will get. So yes, sir, z equals to 0 will be a singularity and it will be a essential singularity. Essential singularity. Say yes or no. Okay. That means if we need to find out the residue, what it would be equals to. Only one singularity is there, that is z equals to 0. You need to find out the residue, what it would be equals to. Sir, it would be nothing but a coefficient of 1 upon z minus a. 1 upon z minus 0. Coefficient of 1 by z in f of z. So now this is your f of z. This is your f of z. In this f of z, you need to find out the coefficient of 1 by z. So now it is simply mathematics, nothing else. It is the mathematical part now. It is not complex analysis. It is your knowledge of mathematics. How much good you are with mathematics, that will be tested here. So what you are supposed to find out? You are supposed to find out the factor of 1 by z. And what will be the coefficient that you will be getting here? That means I need 1 by z. This is my target. What do I need? I need 1 by z. How you can get 1 by z? First of all, what will happen? So this z will be multiplied with all these guys. This z will be multiplied with this one as well, then this, then this, then this. In that manner, it will be multiplied. Right? When you can get 1 by z? Sir, when z is multiplied with 1 by z square, then I can get 1 by z. I only need to care about 1 by z. That means if I multiply this z with 1 by z square, my job would be done. That means if my z is multiplied with minus 1 by z square divided by 2 factorial, then what I will get? I will get a factor of 1 by z. Say yes or no. If z is multiplied with z to the power 4, you will get the factor of 1 by z to the power 3. If z is multiplied with z to the power 6, you will get a factor of 1 by z to the power 5. That means rest all the terms are not my matter of concern. Now I will go to z to the power 3. Now z to the power 3 will be multiplied with all the guys. Now you let me know, from z to the power 3, you need 1 by z. How you can get it? Sir, when I multiply it with z to the power 1 by z to the power 4. That means this z to the power 3 is being multiplied with 1 by z to the power 4. Then the things will be done. That means this z to the power 3 divided with 3 factorial will be multiplied with 1 by z to the power 4 divided with 4 factorial. What you will get? You will get the factor of 1 by z. Say yes or no. Like this is a big expression, no? This big expression will look somewhat like this. Z into 1 plus z into minus 1 by z square 2 factorial plus z into 1 by z to the power 4 4 factorial plus z into minus 1 by z to the power 6 6 factorial plus, in that manner it will look, then plus minus z cube by 3 factorial multiply with 1 plus minus z cube by 3 factorial multiply with minus 1 by z to the power 2 2 factorial plus minus z cube by 3 factorial multiply with this guy, this multiply with this, and so on. Then plus this multiply with this, this multiply with this, this multiply with this, this multiply with this, and so on. In that manner it will keep on going. But I don't need all the factors. I only need 1 by z. I only need to think about 1 by z. Now, sir, z to the power 5 divided by 5 factorial will be multiplied with all these guys. How you can get 1 by z? Sir, I will get 1 by z if it is multiplied with z to the power 6. That means, sir, z to the power 5 divided with 5 factorial, if it is multiplied with minus 1 by z to the power 6 6 factorial, then my job would be done. And similar process would keep on going. Similar process would keep on going. So what you will end up getting? So this z to the power 2 is getting cancelled out. So minus 1 upon 2 factorial z. Here what you will give, here what you will get? 1 upon 3 factorial 4 factorial into 1 by z. Then what you will get? Z to the power 5, z to the power 5. So what you will get, minus 1 by 5 factorial 6 factorial multiply with 1 by z and so on. So what you can see here, minus sign you take outside, minus sign you take outside, or you take yes, let's take minus 1 outside. Inside what you will be getting, 1 by 2 factorial, can I write it down as 1 factorial 2 factorial plus 3 factorial 4 factorial plus 5 factorial 6 factorial and so on 1 by z. So this is your residue. This is your residue. This is the answer. This is the answer. And how it could be written? So it is the summation of some terms. It is the summation of some terms, right? What those terms are? Those terms are, sir, n going from 0 to infinity, minus sign outside, 1 upon 2n plus 1 factorial. If you put n equals to 0 here, it will become 1 factorial. If you put n equals to 2, if you put n equals to 0 here, what it will become? It will become 2 factorial. If you put n equals to 1 here, it will become 3 factorial, 4 factorial. If you put n equals to 2 here, it will become, if you put n equals to 2 here, it will become 5 factorial, 6 factorial. If you put n equals to 3 here, it will become 7 factorial, 8 factorial. So this particular expression could be written in this way. I hope this much mathematics is clear to you. I just wrote down this expression in this way. Say yes or no. So minus sign outside, and this is the answer that we are getting, which is option B. Minus sign outside, 1 upon 2n plus 1 factorial, 2n plus 2 factorial, minus 1 upon 2n plus 1 factorial, 1 plus 2 factorial, and so on. Say yes or no. Understandable? Everything clear? So this is your what this is? This is your residue. Okay, residue at z equals to 0. It is your residue at z equals to 0. Let's go to the next question. So we will go to the next question, but in between we will study a concept. Actually, we are supposed to solve this question. Which question? This question we are supposed to solve. But before that, we need to study some concepts. You try doing this question, you will get wrong answer. Why you will get wrong answer, that also I will tell you. But before that, we already know something, we are just revising it. Do you remember these expressions or these expansions? Yes, sir. 1 plus x to the power minus 1. What did I tell you? You take this minus 1 inside, so it will become 1 minus x, then plus minus will keep on following. So 1 minus x plus x square minus x cube plus x to the power 4. Then you take minus 1 inside, what you will get? Plus sign you will be getting 1 plus x. Then always plus sign will be there. Plus x square plus x cube plus 3x square. You take this minus 2 inside, what you will get? 1 minus 2x, minus sign you are getting, so plus minus will be followed. So 1 minus 2x plus 3x square minus 4x cube and so on. Take this minus 2 inside, what you will be getting? 1 plus 2x plus 3x square 4x cube plus 5x to the power 4 and so on. When these are applicable for this condition, that your mode of x, this guy is less than 1. All these expansions are applicable when mode of this guy is less than 1. You need to expand this. Guy. Okay. You need to expand this guy. So do the expansion. This is what we are asking. For two conditions, mode of z less than 2 and mode of z greater than 2. Let's just ignore these conditions. As of now, let's ignore these conditions. If I need to expand this function, what I will do? Sir, I need to expand this function, so I will write down f of z equals to, can I write it down in this manner? 1 by 2, 1 minus z by 2, or let's write it down in this way. 2 minus z to the power minus 1. If you take 2 outside, what you will get? 1 by 2, 1 minus z. I hope this is understandable to you. 2 minus z to the power minus 1. I am taking 2 outside. So it will go out as 2 to the power minus 1 because there is power minus 1. And 1 minus z by 2 to the power minus 1. So 1 by 2, 1 minus z to the power minus 1. This is what we will be getting. What this will be equivalent to? 1 by 2. Now take this minus sign inside. 1 plus z by 2 plus z by 2 whole square. Take this minus sign inside. So 1 plus z by 2 plus z by 2 whole square plus z by 2 whole cube and so on. So this is the expansion that you are getting. What answer you are getting? 1 by 2 plus z by 4 plus z square by 8 plus z cube by 16 and so on. So sir, this is the answer. But this is the answer for which case? When you are doing this expansion. Like here, which expansion you have applied? You have applied this expansion, no? 1 minus x to the power minus 1. 1 minus x to the power minus 1. This expansion you have applied. So when you are applying this expansion, what is the condition? The condition is that mod of z by 2 should be less than 1. Then only you can apply this expansion. No, mod of this guy should be less than 1. What does that mean? That means mod of z should be less than 2. Mod of z divided by mod of 2 should be less than 1. Mod of z, what is 2? 2 is 2 only. So mod of z less than 2. That means you have written the answer for this case only. Are you able to understand this point? For the other case, the scenario is mod of z greater than 2. Mod of z greater than 2. But we remember the expansions for something less than 1. No. We remember the expansion for something less than 1. But they are asking mod of z greater than 2. Then what I will do? This was the answer of actually first case. Because I remember the expansion for something less than something. That means the first case was mod of z less than 2. Mod of z less than 2. So I could have converted it into mod of z by 2 less than 1. This is what I could have converted it into. So yes, I could apply this expansion. The second case is mod of z greater than 2. Second case is mod of z greater than 2. But sir, I remember the expansions for mod of z less than 1. Now what do I do, sir? What you can do is that you can take mod of z downward, no? So 1 would be greater than 2 by mod of z. That means 2 by mod of z would be less than 1. So now you can apply the expansion for this condition. 2 by mod of z should be less than 1. Now what is your f of z? Sir, my f of z is nothing but 2 minus z to the power minus 1. This is my f of z. 2 minus z to the power minus 1. This is my f of z. Now how I can apply the expansion? Sir, I can apply the expansion only for the condition of 2 by z. I need this expression 2 by z. So what does that mean? What I need to take outside this time? This time I will take z outside. If you take z outside, what will happen? This will become z inverse 2 by z minus 1 to the power minus 1. I have taken z outside. So here 2 by z minus 1 and z inverse will go outside. Along with that, now I need to take minus sign outside as well. Right? I will have to take minus sign outside as well. Why I need to take minus sign outside as well? Because I remember the expression for 1 minus x to the power minus 1. No. 1 minus x to the power minus 1. So I will take minus sign outside as well. So if I take minus sign outside, what I will be getting? Minus z to the power minus 1. 1 minus 2 by z to the power minus 1. So it is coming out to be minus 1 by z, 1 minus 2 by z to the power minus 1. This is what it is coming out to be. Right? So what is your f of z now? Sir, my f of z is minus 1 by z minus 2 by z to the power minus 1. Whenever you have a doubt, no, you should solve it again. Like if you solve it, what you will be getting? Z minus 2 upon z inverse. So minus 1 by z into z upon z minus 2. So this and this is getting cancelled out. What you are getting? Minus 1 upon z minus 2. Yes, minus 1 upon z minus 2, which will be written as 1 upon z minus 2. Are we getting the same expression? Yes, we are getting the same expression. So you can recheck it as well. Okay, so this is how I have rechecked it. Now what I will do? This minus 1 by z remains as it is. Now inside this I can apply the expansion. Inside this I can apply the expansion. So this goes inside. What you will be getting? 1 plus 2 by z plus 2 by z whole square plus 2 by z whole cube. And if you feel like that, sir, I cannot remember it. If you feel like that, sir, I cannot remember the formula, then you can remember at least this formula, no? 1 by x to the power minus 1. So 1 plus x square plus x cube. Okay, so in that manner you can compare. In place of x, you need to put 2 by z. In place of x, you need to put 2 by z. Then 2 by z whole square, 2 by z whole cube, and so on. So what is the answer you are getting? Minus 1 by z plus, minus 1 by z minus 2 by z whole square minus 2 square will be 4 divided by z cube minus 8 divided by z to the power 4 and so on. This is the answer. This is the expansion of f of z. This is the expansion of f of z. This is the answer that we will be. Yeah, let it be here. This is the answer that we will be getting. Minus 1 by z minus 2 by z square minus 4 by z cube minus 8 by z to the power 4 and so on. Is that understandable to you? Okay. So this is the way. Now there is something called Lorentz series. Have we studied Taylor series? Taylor series we have studied. There are two terms, Lorentz series and Taylor series. Taylor series and Lorentz series. So have we studied this series? Yes, sir. Here we have done the expansion, no? What was the expansion of e to the power x? So that was, sir, 1 plus x to the power x square by 2 factorial and so on. What was the expansion of sin x? Sir, it was x minus x cube by 3 factorial and so on. So whichever the expansion that you remember, or whichever the expansion that you have done, in all those expansion, the power was always positive. The power was always positive. Power was always positive. Power is always positive. Always the power was positive. What was your Taylor series? Do you remember your Taylor series? Sir, it was f of a plus x minus a f dash a divided by 1 factorial plus x minus a whole square f double dash a divided by 2 factorial. So power was always positive, no? So in your expansion, if power is always positive, no? If your power is always positive, then it is known as Taylor series. If the power is always positive, power always positive, power always positive, then it is known as Taylor series. And what is the meaning of Lorentz series? That power could be positive as well and it could be negative as well. Power could be positive, negative, both. Power could be both positive and negative. So this is known as Lorentz series. Like here there is negative power only, so this will also be known as Lorentz series. Here there is only positive power, so this will be known as Taylor series. In this question, here it is not visible. In this question you take, there is positive power as well and there is negative power as well. So this is known as Lorentz series expansion. This expansion would be known as, this is your f of z, no? So this expansion is known as Lorentz series expansion. Lorentz series expansion. Because there is positive power as well and there is negative power as well. If there is only negative power, then also it is known as Lorentz series expansion. Like this expansion is also Lorentz series expansion. This expansion is also Lorentz series expansion. Let's remove this. This will also be known as Lorentz series expansion. So there is no new concept here. We already know it. Just the meaning of Lorentz series expansion is that there would be positive and negative power both. That's it. Or only the negative power. If only positive power is there, no, then it is Taylor series. Otherwise, it is Lorentz series. If only positive power is there, then Taylor series. Otherwise, Lorentz series. So this was your Lorentz series. This was your Lorentz series expansion because there was positive power as well and negative power as well. What do you mean by negative power? Sir, it is 1 upon z minus 2 to the power 2. No, so if it goes upward, it will become z minus 2 to the power minus 2. So negative power is there. Here also positive and negative both powers are there. No, this is your negative power and this is your positive power. So this was also your Lorentz series expansion. Understandable? So now you try solving this question. In the Lorentz series expansion of f of z equals to 1 upon z minus 2, for the region mod of z is greater than 1 but less than 2. From here what you can see that, sir, mod of z is greater than 1 but less than 2. What is the coefficient of 1 by z square? You need to find out the coefficient of 1 by z square. This is the question. That means, sir, I will have to find out the expansion. I will have to do the expansion. How will I do the expansion? Do I have any formula for this kind of thing? 1 upon x minus 1 or like what formulas I have? I have only these 4 formulas. No? These formulas I am having. These expansion formula I have. So here these are single guys. These are alone. This guy is also alone. Like it is 1 upon 1 plus x. It is 1 upon 1 minus x. It is 1 upon 1 plus x whole square. It is 1 upon 1 minus x to the power 2. But here there are 2 guys. 1 upon z minus 1, 1 upon z minus 2. What do? I separate them. Partial fraction. Can you do the partial fraction? I hope you know how to do the partial fraction. Here I cannot teach you the partial fraction. Okay. Partial fraction is the basic thing that I can hope that you will be able to understand on your own. So how will you do the partial fraction? The answer will come out to be this. This will be the answer. This will be your f of z. Okay. Here there is condition that mod of z is greater than 1 and mod of z is less than 2. Sir, I remember the formula for mod of x less than 1. That means, sir, mod of z by 2 less than 1 will work for me. But sir, 1 by mod of z, just I am taking the reciprocal, 1 by mod of z less than 1, this will work for me. So these two guys will work for me. Because I remember the formula for something less than 1. So it is something less than 1. Is that understandable to you? So I will do the expansion of this guy separately, I will find out the factor of 1 by z square in this expansion, then I will find out the factor of 1 by z square in this expansion, and then I will add them up. So let's expand 1 upon z minus 2. 1 upon z minus 2. What I need to do? I need to expand 1 upon z minus 2. So that could be written as z minus 2 to the power minus 1. Right? Now what I can do? I can take 2 to the power minus 1 outside, z by 2 to power minus 1 minus 2. 2 I have taken outside, so 2 to the power minus 1 will go outside, z by 2 minus 1. Then another minus sign you take outside, another minus sign 2 you take outside, so it will become minus 1 by 2 to the power minus 1. Understandable? Now if this guy is less than 1, yes, I can apply the expansion. Yes, I can apply the expansion. So minus 1 by 2, 1 minus z to the power 1 minus z by 2 to the power minus 1. This is the thing that I need to do. So what I am getting, 1 upon z minus 2 could be written as 1 upon z minus 2 could be written as minus 1 by 2 1 minus z by 2 to the power minus 1. Now you do the expansion. When you do the expansion, what you will be getting? Minus 1 by 2 you take outside, this minus 1 you take inside. What you will get? 1 plus z by 2 plus z by 2 whole square plus z by 2 whole cube and so on. Now you multiply this minus 1 by 2 inside, so you are getting minus 1 by 2 minus minus 1 by 2 minus z by 4 minus z square by 8 minus z to the power 3 by 16 and so on. This is your 1 upon z minus 2. This is your 1 upon z minus 2. Say yes or no. Next I need to care about 1 upon z minus 1. I know there is a negative sign in between, that I know. Okay, so let's care about directly, let's care about your new function. You take this as phi z, that is minus 1 upon z minus 1, minus 1 upon z minus 1. The scenario is 1 by mod of z should be less than 1. 1 by mod of z should be less than 1. So with that you need to take care. So first of all, can I write it down in this way? Absolutely. What you will take outside? Will you take 1 outside or you will take z outside? I will take z outside. Why is that so? Because sir, if I take z outside, what I will get? 1 minus 1 by z to the power minus 1. Now I have the expansion for this, because 1 by mod of z is less than 1. If I take z outside, so z inverse will go outside. Sorry guys, z inverse will go outside because you are taking z outside, no? So z inverse will go outside. It will become 1 minus 1 by z to the power minus 1. So what you are getting? Minus 1 by z, 1 minus 1 by z to the power minus 1. Understandable? So your minus 1 upon z minus 1 would be equals to minus 1 by z. This is your z only. Minus 1 by z, 1 minus 1 by z to the power minus 1. Is that clear to you? Okay. And let's check as well that it is same only, no? Yes, 1 upon, yes, fine. I am just checking that if this all this process I have done correctly or not. So just you can solve it, no? It will become z minus 1 upon z inverse only. So this is z inverse will get cancelled out. You are getting 1 upon z minus 1. Yes, it is correct only. So now you just need to do the expansion. Minus 1 by z. 1, this minus sign goes inside, so it will become 1 plus 1 by z plus 1 by z whole square divided by 2 factorial plus 1 by z whole cube divided by 3 factorial and so on. So now what you are getting? Minus 1 by z. This will become minus 1 by z whole square. This minus 1 by z I am multiplying inside. So this will become minus 1 by z whole square minus 1 by z whole cube minus 1 by z to the power 4 factorial and so on. In that manner it will keep on going. So this is your minus 1 by z minus 1. This is what you are getting. Okay. So this is your, let's just say this is your phi 2z. This was your phi 2z. And this was your phi 1z. This was your phi 1z. This was your phi 1z. This is your phi 1z. This is your phi 2z. Right. Now what is your f of z? F of z is nothing but, this was your f of z, no? Phi 1z, phi 1z plus phi 2z, because negative sign I have already taken. So phi 1z plus phi 2z. So your f of z is nothing but, your f of z is coming out to be phi 1z plus phi 2z. So what it is coming out to be? Phi 1z plus phi 2z. What is phi 1z? Sir, phi 1z was this expression. Phi 1z was this expression. पूरा कॉपी हो गया यार. So let's write down f of z. F of z will come out to be minus 1 by 2 minus 1 by 2 minus z by 4 minus z square by 8 minus z square by 8 minus z cube by 16 minus z cube by 16 and so on. Then along with that phi 2z will also come. Phi 2z will also come. That would be minus 1 by z minus 1 by z minus 1 by z square minus 1 by z square minus 1 by z cube 3 factorial minus 1 by z cube 3 factorial minus 1 by z cube 3 factorial and so on. It will keep on going, right? What you are supposed to find out? You are supposed to find out the coefficient of 1 by z square. This is the whole expression of f of z. This is the whole expansion of f of z. What you can see, sir, here there is positive powers as well, and then sir we can see the negative powers as well. So both positive and negative powers are there. What does that mean? It is a Lorentz series. So in this Lorentz series, can you let me know what is the coefficient of 1 by z square? Yes sir, coefficient of 1 by z square is nothing but, coefficient of 1 by z square is nothing but minus 1. There you go. This is the answer. Coefficient of 1 by z square is nothing but minus 1. Okay, well and good. So yes, this is the answer. In the examination, it will not take a lot of time. What you will do? First of all, you will write down the equation. These conditions you will get to know, and then quickly you will do the expansion. This expansion you will do separately. Here you would see that, sir, there is no term of 1 by z square. If there is no term of 1 by z square, so from sir this expression you will get 0. And from here what you are getting, sir, there is minus 1. So answer is minus 1. Minus 1 plus 0, answer is minus 1 only. Because here there is no term of 1 by z square, no? There is no term of 1 by z square. That means coefficient of 1 by z square is 0 here. And here the coefficient of 1 by z square is minus 1. So what is the total coefficient? 0 plus minus 1. That would be minus 1 only. So in the examination you will not have to write down this. Directly you will say answer is minus 1. This I wrote down just to let you know that this is how you can expand. Okay. Now solve this question. You need to find out the sum of all residues. What all residue we have? First of all, you let me know what all residues we have. Sir, one residue I can directly see, which is z equals to 1. But sir, this guy will also create some problem. At z equals to 0 as well, you can get a residue. So let's do the expansion in this manner. F of z is 1 upon z minus 1 outside, and I can do the expansion of this guy, which is like this. Okay. Z square 2 factorial 1 by z cube 3 factorial and so on. So you can see that, sir, z minus 1 equals to 0. That means z equals to 1 will be your, if I expand this, what I can see, 1 upon z minus 1 plus 1 upon z minus 1 into z plus 1 upon z minus 1 into z square 2 factorial plus 1 upon z minus 1 z cube 3 factorial and so on. Now you can see that, sir, two guys will create the problem. One guy would be z equals to 1 and other guy would be z equals to 0. So these are my singularities. These are my singularities. These are my singularities for sure. This I already know. Now let me know z equals to 1 is what kind of singularity and z equals to 0 is what kind of singularity. Z equals to 1 is essential singularity. Is that correct? What did I tell you for essential singularity? Sir, for essential singularity, you told me one thing, that the power of 1 upon z minus z naught should be going infinity. But always the power is 1. Always the power is 1. Or if you see this expression as well, in this expression as well, how you are getting z equals to 1? By putting that denominator equals to 0. By putting that denominator equals to 0. What does that mean? This is your simple pole. This is your simple pole. And what is this? Z equals to 0. That means, sir, I can see that 1 by z to the power infinity I will get. 1 by z, eventually 1 by z to the power infinity I will get. So, z equals to 0 is my essential singularity. Say yes or no. This will be my essential singularity. If I need to find out the residue for this one, what will be the residue for this one? Sir, it is very simple. Whoever is creating the problem, remove that guy and put limit z tending to 1. So, z minus 1, f of z I need to do. So, whoever is creating the problem, e to the power 1 by z divided by z minus 1. So, z minus 1 will get cancelled out. Limit z tending to 1, z minus 1, e to the power 1 by z upon z minus 1. This and this will get cancelled out. Z equals to 1 you will put here. What is the answer you will be getting? E. So, this is the residue you have. What is the residue? E. E is the residue. Exponential, which is roughly around 2.7. Roughly around 2.7 something. Now, sir, this is essential singularity, no? So, what will be the residue here? So, residue would be nothing but coefficient of 1 by z in f of z. Coefficient of 1 by z in f of z. So, what will be your R2? Someone says, sir, my R2 would be coefficient of 1 by z. Sir, coefficient of 1 by z. Here, what is the power? Power is 1. So, let's not get confused. Okay, let's remove this power sign. People will get confused only. Yeah. Coefficient of 1 by z in f of z. This is your f of z. Sir, in f of z, coefficient of 1 by z is z minus 1. Or you can say 1 upon z minus 1. So, sir, R2 would be 1 upon z minus 1. This answer is wrong. This answer is wrong. Why is that so? Residue is a number. It was a, here it is a real number. You see all the questions, whatever the questions that we have solved previously. Residue is a constant number. No, this will also be a number only. When you solve it, you will get some answer. No, some numerical answer you will get. Numerical answer, right? Numerical answer, numerical answer. It is a numerical answer. It is a numerical number. Residue is a numerical number. What you have done here? 1 upon z minus 1. This is wrong, no? 1 upon z minus 1. This is wrong. Basically, you have expanded f of z. I have expanded it, but I did not expand it completely. I expanded it, that is fine. But did you expand it completely? You did not do anything with z minus 1. 1 upon z minus 1. You did not do anything with that. You need to expand this guy as well. No, there are two people. In f of z, there are two people. One guy is z minus 1 to the power minus 1, which is 1 upon z minus 1, and other guy is e to the power 1 by z. These are the two guys there. Okay. Now, sir, I need to expand this. Sir, I know the formula for mod of x less than 1. Or you can say, sir, I know the formula for mod of z less than 1. These are the formulas that I know. So, sir, how do I expand it? Basically, sir, can I do in this way? F of z, you take minus sign outside, minus sign you take outside, you will be getting 1 minus z to the power minus 1. Now, sir, I know the expansion of this. Along with that, I surely know the expansion of e to the power 1 by z as well. So, sir, how I can be sure that my mod of z is less than 1? You are sure about it. How you are sure about it? Where you are finding the residue? I am finding the residue at z equals to 0. No, that means my conversation is going with z tending to infinity. Here is my conversation, because I am finding the residue at z equals to 0. And if your z equals to 0, if your z is 0, then surely it is less than 1. No, your conversation is going around z equals to 0. You are finding the residue at z equals to 0. That means you are supposed to expand around z equals to 0. That means mod of z is less than 1. So, yes, this expansion you can do now. Do this expansion. Minus 1 you have taken outside. 1 plus z square plus z cube plus z to the power 4 and so on. What is the expansion of e to the power 1 by z? So, that would be 1 plus 1 by z plus 1 by z square 2 factorial plus 1 by z cube 3 factorial and so on. Now, what you need to find out? You need to find out 1 by z. when you will be getting 1 by z, when I will be getting 1 by z. So sir, 1 by z I will be getting, sir, first of all what will happen, this 1 will be multiplied with all these guys, this 1 will be multiplied with all these guys. If you need 1 by z, that means sir, this 1 should be multiplied with 1 by z, 1 should be multiplied with 1 by z. Sir, 2 should be multiplied with 1 by z square, then you will be, this z should be multiplied with 1 by z square 2 factorial, then what you will be getting, then you will be getting 1 by z, no? So plus 1 by 2 factorial z, then plus, sir, this z square should be multiplied with z cube, so what you will be getting, 1 by 3 factorial z, then sir, this z to the power 4, oh sorry, this z to the power 3 should be multiplied with, z to the power 3 should be multiplied with 1 by z to the power 4, 4 factorial. So this z to the power 3 should be multiplied with this guy, z to the power 3 should be multiplied with 1 by z to the power 4, 4 factorial. So what you will be getting, 1 by z 4 factorial. So plus 1 by z 4 factorial and so on. I am only caring about the factor of 1 by z because I need to find out the coefficient of 1 by z. So I am only caring about the factor of 1 by z. So what you are getting, minus 1 outside, 1 plus 1 by 2 factorial plus 1 by 3 factorial plus 1 by 4 factorial and so on 1 by z. So what is the coefficient of 1 by z? Sir, your coefficient of 1 by z is coefficient of 1 by z in f of z is coming out to be, that means this is your residue R2, that is coming out to be, minus sign you take outside, minus sign you take outside, 1 plus 1 by 2 factorial plus 1 by 3 factorial plus 1 by 4 factorial and so on. But this has a separate answer, this has a certain answer. What is the answer? Like in the examination this option will not be mentioned. Let's just say this option is not mentioned, something else is mentioned. What else could be mentioned? Sir, is this my answer correct? Yes, this answer is correct. But let's just say in the examination this option is not even mentioned, then what you will do? Sir, I remember the expansion of e to the power x, that is 1 plus x square by 2 factorial plus x cube by 3 factorial and so on. Now sir, let's do one thing. What will be e to the power x minus 1? You take this minus 1 outside, what you will be getting, 1 plus x square by 2 factorial plus x cube by 3 factorial and so on. Now in place of x you put 1, what answer you will get? In place of x I put 1, so what answer I am getting? 1 plus 1 by 2 factorial plus 1 by 3 factorial and so on. So 1 plus 1 by 2 factorial plus 1 by 3 factorial plus 1 by 4 factorial, what it is? It is nothing but e minus 1. So what is the answer you are getting? 1 minus e. This is your R2. This is your R2. So your R2 is, R1 is e and R2 is 1 minus e. So what is your summation of R? That is R1 plus R2. E plus 1 minus e. So your summation of R is coming out to be 1. In the examination till this date, these kind of questions are not asked. Okay. To be very honest, they don't ask this much of a tough expression. Here there is a lot of concept involved, no? Like first of all, z equals to 1 is a simple pole, sir, very easily I could find out. Then sir, z equals to 0 is also there. Z equals to 0 is also there, sir. Now for z equals to 0, z equals to 0 is an essential singularity. So that means I need to find out the coefficient of 1 by z in f of z. Now how do I find out the coefficient of 1 by z in f of z? Sir, if I do this process, sir, if I expand in this manner, then I see a coefficient of 1 by z is coming out to be 1 upon z minus 1. 1 upon z minus 1, that is absolutely incorrect, sir. If it is incorrect, that means what error I have done? I forgot to expand. I need to expand this guy as well. So this is how I will expand it and this is how I will get the answer. What is the answer I am getting? 1 minus e. Okay, so summation is 1. Now next question we are going to solve, which will be even tougher than this. Okay, which will be even tougher than this. So we will solve that, but I will have to change the slide. I will take some break as well. So after changing the slide, I will write down that question and then we will solve it. Okay. Is that clear to you? So because more pages I cannot add. Understandable? Yeah. So I hope you would have understood this question. That if there is some other kind of singularity is also present, no? That means you will have to expand the whole expression. The whole expression needs to be expanded. That means this 1 upon z minus 1 should also be expanded and e to the power 1 by z should also be expanded. Understandable? And sir, what about this question? This is a gate QIQ actually. So yes, in gate examination, these kind of questions are asked, that you simply do separation and they are asking you this. In gate examination, how this question could be asked? They will write down f of z equals to e to the power 1 by z, z minus 1. They will ask, in the Lorentz series expansion of f of z, find out the coefficient of 1 by z. Find out the coefficient of 1 by z. This option will also be mentioned. So that would be wrong. Coefficient of 1 by z would be 1 minus e. And how we got the answer? This is how we got the answer. So yes, in the syllabus, Lorentz series is mentioned. But Lorentz series and residue both are interrelated. So they can give this expression and they can ask you, find out the coefficient of 1 by z in f of z. So what will be the coefficient of 1 by z? That you will be able to find out. Understandable? So let me take a break and then I will come back and we will solve one more question. Similarly, somewhat like this. Okay? Yeah, welcome back. So now we need to solve this question. Look, it's a very good question. These kind of questions are not asked yet in the examination, but it may be asked in the future. Okay? Try doing it on your own. When you do it on your own, you will realize that something wrong you are doing. You know that, sir, we will have to do the expansion. Z equals to 1, it is a simple pole, sir. Z equals to 2 is a essential singularity. Expansion I will have to do. How will you do the expansion such that your coefficient of 1 upon z minus 2 comes out to be a number? It could be a complex number, it could be a real number. Okay, so do the expansion on your own, then you will realize that something wrong I am doing. Okay, let's get started. So you will be able to find out the singularity, no? What is your f of z? Sir, f of z is nothing but e to the power 1 upon z minus 2 divided by z minus 1. Okay, this is your f of z. Now you know that, sir, if I put denominator equals to 0, then I can see that z equals to 1 will be a simple pole only. And sir, if I do the expansion, then I can directly see that this guy will also create the problem. Z equals to 2 will also create the problem, and it will come out to be a simple pole, not simple point. Simple pole, and z equals to 2 will come out to be a essential singularity. Essential singularity. Can you find out R1 for this, residue for this? Yes, sir. What will be residue? That would be limit z tending to 1, limit z tending to 1, and this z minus 1 will get cancelled out because this is creating the problem, and simply I will put z equals to 1 here. E to the power 1 upon z minus 2. So z equals to 1 you will put here. What is the answer? 1 by e is the answer. So residue with respect to z equals to 1 is 1 by e. What will be the residue with respect to z equals to 2? Here you need to find out the residue for this. Right? So what will be your residue? So for that, what I need to do, sir? I need to do the expansion. So I need to expand f of z. How will you expand f of z? Sir, e to the power 1 upon z minus 2, that I can expand very easily. Let's keep this guy as it is. E to the power 1 upon z minus 2. Sir, it would be 1 plus x plus x square by 2 factorial plus plus minus nothing. E to the power x. E to the power x is 1 plus x square by 2 factorial plus x cube by 3 factorial and so on. In that manner, it would keep on going. X cube by. It feels that I am sleepy, but I am not sleepy actually. Okay, don't feel that, sir, your efficiency is going down. It's fine. It's just that expansion I did not write down in a good way. Yeah, so this is the expansion that I have done. Now the important step would come. Now you know that, sir, this guy also I need to expand, because from here if I see what is the coefficient of 1 upon z minus 2. What is the coefficient of 1 upon z minus 2? So that is 1 upon z minus 1. Doesn't make any sense. If you just simply multiply z 1 upon z minus 1 inside, then coefficient of 1 upon z minus 2 is coming out to be 1 upon z minus 1. That will not make any sense, sir. That means, sir, this guy needs to be expanded as well. Where your discussion is going, you need to expand around z equals to 2, right? What you are finding? You are finding the residue near z equals to 2, right? If someone is saying that, sir, I will take it upward, this will become my z minus 1 inverse, or I can write it down as 1 minus z inverse. In that manner I can write down, and then, sir, I will expand it in this way: 1 plus z square plus z cube and so on. So in this way I will expand. So this is applicable only when this your mode of z is less than 1, no? Here your value of z is 2. That means mode of z is actually 2. So it is not less than 1. So first of all, this expansion you cannot do. This expansion is wrong. Secondly, you are expanding about z equals to 2, no? So what you will do is that if someone would say that, sir, okay, this is mode of z is 2, mode of z is 2. That means, sir, mode of z by 2 will be equals to 1. So, sir, how would I expand? Now there is a problem, right? So what you do is that your z equals to 2 is given, right? You are expanding around like your discussion is going around z equals to 2. So can you write down this thing that z minus 2 would be equals to 0? If z is 2, that means mode of z minus 2 would be equals to 0. That means mode of z minus 2 would be less than 1. So you can expand around mode of z minus 2, or you can say I will expand around z minus 2. What I mean to say is that this function is given, no? Which function? Z minus 1 inverse. Z minus 1 inverse. I will better write it down in this way. What I need z minus 2. So I will write it down as 1 plus z minus 2. What it will become? Z minus 1 only, to the power minus 1. Is that understandable to you? This z minus 1 inverse I have written in this way, 1 plus z minus 2 inverse. And now I can expand. How I can expand? Because, sir, this particular thing, z minus 2 is nothing but 0. So that is 0. That means, sir, mode of z minus 2 is less than 1. Yes, now I can expand. How will you expand? Sir, let's take this minus sign inside. In that manner you will expand. What formulas do you remember? Which formulas do you remember? Sir, 1 minus x to the power minus 1, 1 minus x to the power 1 plus x to the power minus 1, 1 minus x to the power minus 2, 1 minus x to 1 plus x to the power minus 2. These formulas you remember, right? So here you can apply this formula. Which formula? This formula you can apply. 1 minus x plus x square minus x cube and so on. This will be minus x cube and so on. So this same formula I will apply. 1 minus x plus x square minus x cube and so on. So from here what you will see that, sir, my f of z is actually coming out to be 1 minus, let's keep it aside, f of z is coming out to be 1 minus z minus 2 plus z minus 2 whole square minus z minus 2 whole cube and so on. And here this expression I need to write down, which is 1 plus 1 upon z minus 2, 1 plus 1 upon z minus 2 plus 1 upon z minus 2 whole square divided with 2 factorial plus 1 upon z minus 2 whole cube divided by with 3 factorial and so on. Right? Now what you need to find out? You need to find out the coefficient of 1 upon z minus 2. What we need to find out? Something with the coefficient of 1 upon z minus 2. I need to find out the coefficient of 1 upon z minus 2. So let me know how you can get 1 upon z minus 2. So, sir, first of all, this 1 needs to be multiplied with 1 upon z minus 2. I will get 1 upon z minus 2. Then, sir, this guy should be multiplied with this guy, right? Z minus 2 should be multiplied with 1 upon z minus 2 whole square divided by 2 factorial. So what I will get, sir? Minus 1 by 2 factorial. 1 upon z minus 2 whole square divided with 2 factorial is multiplied with minus sign outside, minus z minus 2. So what you are getting? 1 upon z minus 2, 1 by 2 factorial. So minus 1 by 2 factorial. Now this particular thing should be multiplied with this particular thing. So what you will be getting? Here there is plus sign. So plus 1 by 3 factorial. Next, one more term if I want to write down, what term I will be getting? So here it would be 1 upon z minus 2 to the power 4 divided with 4 factorial and so on. So this guy needs to be multiplied with this guy. So what you will be getting? Minus 1 by 4 factorial. And it will keep on going. Say yes or no. Did you understand this point or not? So are you getting a constant coefficient? Yes. In any other expansion, if you would have done this expansion or anything else, although that would have been already wrong, because you did not even see that your discussion is going around z equals to 2. So already that would have been wrong. In the previous question, sir, we did not need to think all these things, that discussion is going around z equals to 2 or not, because there the discussion was going around z equals to 0. So there already your mode of z was less than 1. Now you need to make mode of z less than 1. What does that mean? That means, sir, I will make z minus 2 here. Z minus 2 would go to 0. So mode of z minus 2 would become 0 only. That means mode of z minus 2 would be less than 1. Understandable? And this is how I will expand it. That I will make the function as 1 plus z minus 2 to the power minus 1. Now what this is equivalent to? So for that we need to look at exponential to the power minus x. What is the expression of what is the expansion of exponential to the power minus x? That is nothing but 1 minus x plus x to the power 2 minus x to the power 3 divided with 3 factorial plus x to the power 4 divided with 4 factorial and so on. You put x equals to 1. 1 minus 1 plus 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial and so on. What we need? We need 1 minus 1 by 2 factorial and so on. So let's do one thing. Let's take this one as this side. So it would become 1 by e minus 1 minus 1 plus 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial. Now let's do one thing. Multiply with negative sign on both of the side. So 1 minus 1 by e would be equals to 1 minus 1 by 2 factorial plus I am multiplying with the negative sign both of the side, right? Plus 1 by 3 factorial minus 1 by 4 factorial and so on. So what this is equivalent to? This is equivalent to 1 minus 1 by e. So this particular thing is equivalent to 1 minus 1 by e multiply with 1 upon z minus 2. So what is your R2? That is coming out to be 1 minus 1 by e. Okay, so R2 is 1 minus 1 by e, and what is R1? R1 was 1 by e. So here you can see R1 was 1 by e and R2 is 1 minus 1 by e. So what is your summation? What is your summation R? The summation R is nothing but 1. Understandable? This was your R1, this is your R2, this is your summation R. If you are able to solve it on your own, then it is pretty good. Okay, if you are able to solve this kind of question on your own, then it was pretty good. Okay, so always you need to see that, sir, around which I am expanding. So always you make sure that this particular thing z equals to 2 is there, no? So you make you take 2 this side and you make z minus 2 equals to 0, no matter whatever the number was. If it was z equals to 4, you would make z minus 4 equals to 0, then you would expand it. So that, sir, what I would see is that, sir, everything is coming around z equals to 2 now. Z equals to 2 now. This expansion is around z equals to 2. So if you are doing the expansion around z equals to 2, this is also around z equals to 2. So now you can find out the coefficient of 1 upon z minus 2, which will be a constant number. It could be a real number, it could be a complex number, that I don't know. But yes, it is a constant number, which is 1 minus 1 by e. It is about nearly 0.63. So yes, it is a constant number that you are getting. Are you able to understand this point? So if we need to get a constant number, that means if we need to find out the coefficient of 1 upon z minus 2, that means we need to expand in a way that, in which way? We need to expand in a way that our expansion is about z equals to 2. Our expansion is always about z equals to 2. So here I am writing expand it about z equals to 2. Expand about z equals to 2. Expand it about z equals to 2. So how will I expand it about z equals to 2? That means I need to make a term of z minus 2. I need to make a term of z minus 2. That means I need to make this term z minus 2. This is how I will be expanding it. Right? So I did it and got the answer. Understandable? This was a very good question. Let's move to the next one. This is a gate PYQ only. You try solving it on your own. Sir, you need to find out the residue of f of z at the pole z equals to iota. Which pole they are talking about? Z equals to iota. Sir, where will be the singularities? For sure you know that, sir, here the singularity will be pole type only. It could be simple pole, it could be multiple pole, it could be removable pole. But surely, sir, it will be pole type only. That means, sir, I need to put my numerator equals to 0. If I put my numerator, which is 2z to the power 4 minus 3z cube plus 7z square minus 3z plus 5 equals to 0, sir, now I will get some 4 values of z. When I solve it, I will get some 4 values of z. They will be my poles. Now, sir, z equals to iota is one of the poles that they are already saying. that z equals to iota is one of the pole that they are already saying, and you find out the residue only at that pole only. Now let me know if z equals to iota is a simple pole or repeated pole or a removable pole. Is it this guy is a simple pole, or it is multiple pole, or it is removable pole? Sir, it cannot be removable pole, which I can directly see. Why it cannot be removable pole? Because sir, at z equals to iota, this particular function is becoming 6 iota. So 6 iota divided by, so at z equals to iota, what will be the scenario? 6 iota divided by 0, which is coming out to be infinity. That means, what does that mean? It cannot be removable pole. Because for removable pole, the condition would become 0 by 0, right? So it cannot be removable pole. Now the thing is whether, sir, it is a simple pole or multiple pole. That's the question. Now this is your polynomial with real coefficient. Say yes or no. Polynomial with real coefficient. Look, this question have been solved in the PYQ's book, but they have already considered it as a simple pole only. But what is the reason that it is a simple pole? Why it cannot be repeated? So that I am telling. So this is a polynomial with real coefficient. If it is a polynomial with real coefficient, then the roots will be coming in complex conjugate, that we have already seen in the basics. If it is a polynomial with real coefficient, then the roots will be coming in complex conjugate. That means if one of the root is iota, then surely another root would be minus iota for sure. That's guarantee. If one root is iota, then other root would be minus iota for sure. Now let's just say I assume that iota is a repeated pole. It is being repeated. That means another root has to be iota, and if another root is iota, then another root has to be minus iota as well. If one of the root is iota, then sir, another root has to be minus iota. That's for sure, sir. If I am assuming that this iota is being repeated, that means iota is root but twice. If it is being repeated, then the other root has to be minus iota as well. Now what is the summation of roots? So the summation of roots is 0. But what is the actual summation of root? Sir, actual summation of root is 3 by 2. What I am asking is that sum of roots is actually 3 by 2. Sum of roots is actually 3 by 2. But if you consider iota as a repeated pole, then the sum will come out to be 0, which are not same. That means this is not possible. There you go. Is that understandable to you or not? So the rest of the two poles, which I don't know, they will have the multiplication of 3 by 2, because you can see plus minus multiplication of 3 by 2, and sorry, not multiplication, sorry guys, they will have the summation of 3 by 2, and multiplication of plus minus plus minus plus, and multiplication of 5 by 2. This will be the scenario of the other roots. Two other roots would be there, no? With the summation, they will give you the result of 3 by 2. With the multiplication, they will give you the result of 5 by 2. I don't know what these roots are, but this would be the scenario. Are you able to understand this point? So you can make a quadratic equation and you can solve it. If you solve this quadratic equation, no, then whatever the answer that you are getting after solving this quadratic equation, they will be the other roots. Two roots would be iota, other root will be minus iota. Now two more roots will be there, no? So those two more roots will be satisfying this equation. They will be satisfying this particular equation. Is that understandable to you? Okay. So surely z equals to iota is a simple pole but not a multiple pole. So this was the beauty of the question, although people just directly consider that it is a simple pole only. But why it is a simple pole? That you tell, no? It cannot be a repeated pole. That, sir, because sir, if it is repeated, then other roots has to be minus iota. That means sir, summation would come out to be 0, but actually the summation is 3 by 2. There you go. Okay, or you can see by the multiplication as well. Sir, here the multiplication, if this is the scenario, then multiplication will come out to be, sir, plus 1, but actually the multiplication is 5 by 2. So multiplication is also not satisfying. Okay, so anything you can see, summation, multiplication, whatever you want to see. That means it cannot be a multiple pole as well. So it has to be a simple pole. And if it is a simple pole, then what will be the residue? So residue would be nothing but, so what you will do? Will you go with the first method or second method? I will go with the second method. What I will do, numerator as it is, what I need to put, z tending to iota. Numerator as it is, divided by the numerator divided by differentiation of a denominator. So what will be the differentiation of denominator? 8z cube minus 9z square plus 14z minus 3. And now I will simply put iota here. What I will get? 6 iota divided by, iota cube will be minus iota, so minus 8 iota plus 9 plus 14 iota minus 3. So this will become 6 iota, this will also become 6 iota. So it will become iota upon iota plus 1. Okay, iota upon iota plus 1. Say yes or no? सही तो कराओ ना भाई. 6 iota, yes. Or you better you write down iota upon 1 plus iota. Iota upon 1 plus iota. So iota into 1 minus iota divided by 2. So iota minus iota square. So 1 plus iota by 2. So answer is 1 plus iota by 2. When you solve it, you can do the rationalization and you will get the answer to be 1 plus iota by 2. What I have done is that answer is iota upon 1 plus iota. No? So I have multiplied 1 minus iota divided with 1 minus iota. So upper side what you are getting, iota minus iota square divided by 1 minus iota square. So what you are getting, iota plus 1 divided by 2. So 1 plus iota by 2. That's the answer that we are getting. Okay. Very simple process. So this was the question. Understandable? So first of all, I need to prove that z equals to iota is a simple pole. Now if it is a simple pole, then sir, how would you solve it? Will you multiply this function with z minus iota or anything like that? No. What I will do is that, sir, I know the method, numerator as it is, differentiation of the denominator. Then simply put z tending to iota. Now someone might be having the doubt that, sir, how this method came. So this method is something that we already know. How this method came, sir? Let's just say I am given f of z as numerator by denominator. This is what f of z is given. Okay, numerator by denominator. This was denominator actually. Numerator by denominator. Now if I put dz equals to 0, and then I solve it, then z equals to z naught is my simple pole. Z equals to z naught is my simple pole. Now what I am supposed to find out? I am supposed to find out the residue here. So what will be my residue? So residue will be nothing but r. That would be limit z tending to z naught. What is the method? The method is, sir, you multiply with z minus z naught, n of z divided by denominator of z. Now denominator of z was 0 when denominator of f of z was 0 when z was equals to z naught. So what does that mean? D of z naught equals to 0 only, no? Right? Because if you put z equals to z naught, then denominator is coming out to be 0. So d of z naught is 0 only. Now sir, if I put this z naught directly here, what I will get? If I put this z naught directly here, so sir, z naught minus z naught into numerator of z naught divided by denominator of z naught. So z naught minus z naught is 0 by 0. So what I can do? I can apply L'Hopital rule. So what will be your residue? Limit z tending to z naught. First one as it is, differentiation of numerator plus, I am applying L'Hopital rule, upper side differentiation and down side differentiation. Then numerator as it is and differentiation of z minus z naught will be 1 divided by differentiation of denominator. And now you put z equals to z naught here. What answer you will be getting? Sir, if I put z equals to z naught here, z naught minus z naught will be 0. 0 multiplied with n dash of z will be 0 only. So what you are getting? Nz, what you are putting? Z naught you are putting. Or better I should say, limit z tending to z naught. Here if I am putting z naught, so this will be gone. This will become mz divided by, and isn't it your phi of z? Isn't it your phi of z? Limit z tending to z naught, phi of z. So how we used to define the phi of z? We used to define the phi of z in this manner, that's our numerator as it is, differentiation of the denominator, and then you put a limit z tending to z naught. This is the process that we used to do. So this was the process that is same only actually. It has been derived, the method 2 has been derived from method 1 only. Right? This method 2 which we do, that has been derived from method 1 only, but both you need to remember. Here, if you go by this method, that's if I will multiply with z minus iota, then it would take a lot of time, because here you will have to make the factors and all. So those factors and all we will not make. What we are doing? We are going directly, I know the methods are numerator as it is, differentiation of the denominator, simply put z equals to iota, your job is done. First we need to prove that z equals to iota is a simple pole. This was the condition. Right? So same thing we have done here. So here what we did was, we went with the same method that sir, you need to multiply with z minus z naught, because that is the problem, it will cancel out. Then sir, if I put z equals to z naught here, it is coming out to be 0 by 0 form. I applied the L'Hopital rule, numerator as L'Hopital rule I am applying, that means upper side differentiation divided by downward side differentiation. So upper side differentiation divided by downward side differentiation. So this will become d dash z, and this will become, this is the differentiation you can do first as it is differentiation of second plus second as it is differentiation of first. Okay, just put the limit, you will get the answer. Understandable? So this is the answer that we are getting. Numerator as it is differentiation of a denominator, and simply put the limit z tending to z naught. Easy question. Let's go to the next one. Singularities and residue. Not very tough, it is very simple only. So what is your f of z? Let's write it down in a good way. So sir, f of z is coming out to be z square plus 1 divided by z square and here whole square. This z is going here, this will become z square plus 1 divided by z, and this whole square I am taking, so z square plus 1 whole square divided by z square. This is what we are getting. Where is the problem? So the problem will be when your denominator is coming out to be 0, which is z square being equals to 0. That means problem will be there at a 0 comma 0. That means z equals to 0 will be repeated poles, right? Z equals to 0 will be repeated poles. Understandable? And what is the method of repeated poles? So method of repeated pole is, what is the residue? So residue would be limit z tending to 0. What I will do now? That sir, whoever is creating the problem, remove that. But sir, since it is repeated of order 2, since it is repeated twice, then I will have to differentiate it one time. Which function I need to differentiate? After removing this guy, whatever that I am left with, I need to differentiate it one times and then divide it with 1 factorial. Understandable? So what you are getting? I am getting limit z tending to 0 to z square plus 1 into 2z. Put z tending to 0 here. What is the answer? 0 only. So what is the residue? Residue is coming out to be 0. Okay. So what is the residue? Residue is coming out to be 0 only. Understandable? Okay, you do this question on your own. Let me take a break. I will drink some water. You do this question on your own. Yeah. So did you solve it? The question is f of z equals to, this function is given, you need to find out the sum of residues. So f of z is nothing but z square upon, so the downward function could be written as z minus 2 into z minus 2 into z minus 1. Say yes or no? Say yes or no? Z minus 2 into z minus 1, and then it's a whole square. So what is the answer you are getting? Z square upon z minus 2 whole square, z minus 1 whole square, right? Which is numerator by denominator. So if you put a denominator equals to 0, I don't remember in this lecture only, previously am I writing numerator equals to 0? Although we are putting denominator equals to 0 only, but I am not sure whether I am writing nz equals to 0 or what. Denominator equals to 0, okay? dz equals to 0. So if I put a dz equals to 0, what I am getting? Z minus 2, z minus 1 whole square equals to 0. So what is the value of z? The value of z is 2, 2, 1, 1. Are you able to understand this point? Here there is square, no? Here there is square. Although sir, roots will be 2 and 1 only, but both are repeated poles. No, both are repeated poles. Both are repeated poles. Repeated poles of order 2, right? So what you need to find out? Residue at z equals to 2. Residue at z equals to 2. So first I need to find out residue at z equals to 2. So what that would be? So that would be nothing but limit z tending to 2. Now whoever is creating the problem, that means z minus 2 is creating the, z minus 2 whole square is creating the problem. So I will remove it. What I will be left with? Z square upon z minus 1 whole square. So it would be a lengthy question, a bit lengthy question it would be. So dy dz, what differentiation you need to do? Z square upon z minus 1 whole square. Okay. So this is the differentiation that we are supposed to do, divided with 1 factorial. And then you need to put z tending to 2 here. So first you differentiate. Differentiation of z upon z minus 1 whole square. So this differentiation we are supposed to do. Look, I have a short method for this. What I will do? Z upon z minus 1 whole square it is, no? So can I do z plus 1 minus 1 or z minus 1 plus 1, z minus 1 plus 1 divided by z minus 1. So it would come out to be 1 plus 1 upon z minus 1 whole square, right? This is what I can do. Now I need to differentiate this function. So what I will do? 2 outside, 1 plus 1 upon z minus 1, and then differentiation of inside will be minus 1 upon z minus 1 whole square, right? So this is what I am getting. So what is the answer I have? अरे भाई ये क्या कर रहे हैं, माइनस साइन आउटसाइड रहेगा ना यार, ठीक है. You are differentiating this part, no? So minus will come outside. So minus 1 upon z minus 1 whole square. You are differentiating this function now, inside function. You need to differentiate the full function. So first what I did, first I did x to the power n. That would be n x to the power n minus 1. So 2 outside I took 2 1 plus 1 upon z minus 1. Then I differentiated the inner part. That would be minus 1 upon z minus 1 whole square. Minus 1 upon z minus 1 whole square. So what you are getting? Minus 2z upon z minus 1 to the power 3. Right? Minus 2z upon z minus 1 to the power 3. So what you are getting? Limit z tending to 2 minus 2z upon z minus 1 to the power 3. And then you put z tending to 2 here. What is the answer? Minus 2 upon z tending to 2. If you put, this will be minus 4. Yes, answer is coming out to be minus 4. Okay, so differentiation we need to do. It is a bit lengthy process, but smartly you need to do the calculation. Now residue at z equals to 1, right? Residue at z equals to 1 now. So residue at z equals to 1. Again, repeated poles are there. Limit z tending to 1 d by dz of z square upon, this guy will get cancelled out. Z minus 1 whole square is creating the problem. So what you will be left with? Z minus 2 whole square. Right? So it would be z minus 2 plus 2 upon z minus 2 whole square. This is what we can do. So it will come out to be 1 plus 2 minus, now differentiation you need to do. So 2 into 1 plus 2 minus z, 2 z minus 2 whole square, and then minus sign. So what you are getting? This will be z here. So minus 4z upon z minus 2 whole square. Say yes or no? सही है ना भाई? लग तो सही रहा है. Differentiation z upon z minus 2 whole square, z upon z minus 2 whole square. So z minus 2 plus 2, 1 plus 2 upon z minus 2. 2 you outside you take 1 plus z minus 2, and then you differentiate this part, which will come out to be with the negative sign. It will give you this part. That's it. So z minus 2 upon z minus 2 whole cube, z for minus 4z upon z minus 2 whole cube. So what you are getting? Limit z tending to 1 minus 4z upon z minus 2 whole cube. There you go. This is what we are getting. Okay, after the differentiation, you can do it on your own. Differentiation and everything you should be able to do. Now you put z equals to 1 here, what you will be getting? This will be answer coming out to be 4. So your residue, one residue is coming out to be minus 4, other residue is coming out to be plus 4, and summation is 0. This is also a gate QIQ as well. Okay, this question is also a gate QIQ only. So yes, this kind of lengthy calculation is also asked, that whenever you are supposed to differentiate, this differentiation also you might need to do. But smartly you can do the differentiation. You can see that, sir, it is coming out to be z upon, or this one is z upon z minus 2 whole square. So sir, if I add minus 2 plus 2, then it will become 1 plus 2 divided by z minus 2 whole square. And sir, this differentiation is a bit easier. 2 I can take outside, so 2 into 1 plus 2 upon z minus 2, and then simply differentiate this part. So this differentiation might be a bit easier. Okay, so yeah, this is the calculation. Just for the calculation purpose I took this question. Otherwise it is very straightforward. You should be able to do it on your own. And this is the important part, that it is power 2. That means it will become a power 4 equation. It is a power 4 polynomial. It looks like quadratic, but it is actually power 4. Why is that so? Because z square to the power 2, it will become power 4. Understandable? Next, this is actually a very good question. Okay, you need to find out the sum of all the residues of f of z lying inside the circle mod of z equals to 7. So for finding out the residues, how will you find out the residues? Do you need to do the expansion here or anything like that? Absolutely not. Who will create the problem? Sir, first guy is this, that if z is 0, it will create the problem. Or sir, if, or you can directly say that, sir, if z into sin z is 0, no? If z into sin z is 0, then there is a problem. Or you can say that, sir, if z is 0, or if sin z is 0, then there will be a problem. So z equals to 0 will create a problem. And sir, sin z equals to 0. What does that mean? That means, sir, z equals to 0 plus minus pi plus minus 2 pi. And sir, plus minus 3 pi will also come, but that will not be included because, sir, this is 0, this is plus minus 3.14, and this is plus minus 6.28, and this will be whatever it is, 9 point whatever it is. It will not be included, right? Rest all the parts will not be included. So 5 guys will be included. But did you notice one thing? Z equals to 0 is coming twice. Z equals to 0, he is saying that I will create the problem here as well, and he is saying that I will create the problem here as well. Z equals to 0. That means your poles are 0, 0, plus pi, minus 2 pi, and plus 2 pi. These are your poles. But this guy Z equals to 0 is actually a repeated pole or multiple pole. Repeated pole or multiple pole. Say yes or no. Z equals to 0 is a repeated pole, right? And if Z equals to 0 is a repeated pole, then how will you find out the residue? Residue at Z equals to 0. What will be the process? Since it is a repeated pole, sir, what will be the process? So process would be that I need to find out the residue here. That would be limit Z tending to 0. What I will do? It is repeated how many times? It is repeated 2 times. That means, sir, I will have to divide with 1 factorial and I will have to multiply once. What I need to multiply? Sorry, I will have to divide with 1 factorial and then I will have to differentiate once. What I need to differentiate? You need to differentiate z square f of z. This is what you need to differentiate. I hope you remember, if z equals to z naught is a repeated pole of order n, then what you do? Order n, then what you do? Then what you do is that you divide with n minus 1 factorial, then you differentiate n minus 1 z minus z naught to the power n f of z and limit z tending to z naught. This is your residue. I hope you remember this. Process we already know. What is the process? That's sir, whoever is creating the problem, remove that guy. Whoever is creating the problem, remove that guy. So z square was creating the problem actually. Z into z is creating the problem. So I remove that guy by multiplying with z square. That's it. And then one time I need to differentiate, 1 factorial I need to divide, and z tending to 0 I need to put. So what I will be getting? R1 equals to limit z tending to 0 d by dz z square into f of z. What is f of z? F of z is 1 upon z by sin z. Right? So what we are getting? Limit z tending to 0 d by dz of z by sin z. So first you find out this thing. You cannot take limit inside this time because here there is a term of z, no? Limit inside you cannot take. So differentiate now. What you will be getting? Sin z square. So sin z first as it is, differentiation of second, minus second as it is, differentiation of first, and limit z tending to 0. If you put limit z tending to 0, what you will get? This is also a gate PIQ only. Okay, it is also a gate PIQ, but they only asked at z equals to 0 actually. They only asked at z equals to 0, but I will ask at pi minus pi at all those points as well. So what you will do now? You will put z tending to 0. If you put z tending to 0 here, what you are getting? Sin 0 is 0 only. 0 minus 0 divided by sin 0 is 0. Again, what it is? It is indefinite form. That means you have to apply L'Hopital rule. So how will you apply L'Hopital rule? For applying L'Hopital rule, sir, differentiation of the upper side, what that would be? Cos z minus differentiation of this function. First as it is, differentiation of second, minus second as it is, differentiation of first, divided by differentiation of downward as well, 2 sin z cos z. Now you put z equals to 0 here. So what is the answer you will be getting? 1 cos 0 is 1 plus 1. Infinite answer. है जी, इनफाइनाइट आंसर कैसे आ रहा है भाई? cos 0 is 1, sin 0 is 1. This is also 1. क्या दिक्कत है भाई? Let me check the calculation. Yeah, so a big blunder here. It will be a plus sign. No, I don't know why I put negative sign. Like negative sign is already outside. So first one as it is, differentiation of cos z will be minus sin z, plus the second as it is, cos z as it is, and differentiation of z would be 1 only. So this will be a plus sign only. So what you are getting here? What we are getting is limit z tending to 0. This cos z minus cos z will become 0. So upper side you are getting z sin z, downward side you are getting 2 sin z cos z, 2 sin z cos z. So now you can see that sin z and sin z is getting cancelled out. Now you put the limit z equals to 0. This will become 1. So limit is coming out to be 0. So what is the residue you are getting? Residue you are getting is 0. So this was the error from our side, that here the limit, here the differentiation we did wrong. Okay. So the residue at z equals to 0 is coming out to be 0. So why it was a multiple pole? That was the beauty of this question. Z sin z is there, no? So what does that mean? Sir, sin z will also say that at z equals to 0 I will make it 0, and z equals to 0 will also say that at z equals to 0 I am making it 0. So at z equals to 0 there is a multiple pole. At z equals to 0 there is a pole of order 2. So pole of order 2 would say that you multiply with z square, and then whatever the function that you get, you put the limit, then you differentiate that function, and then you divide it by 1 factorial, and then you put the limit z tending to 0. Okay, this method we have applied here. Our z naught was 0 only, so this became z square f of z. Understandable? Okay, so go to the answer. Now what about other guys? Pi, minus 2 pi, all these points. So all these are simple poles, right? All these are simple poles. All these are simple pole. So they are simple pole now. Now our function is f of z equals to 1 by z sin z. What I need to find out? I need to find out residue at z equals to pi. This is what I am supposed to do. What does my method say? My method say one thing, that your residue at z equals to pi would be limit z tending to pi z minus pi f of z, which is z minus pi f of z. So it is coming out to be limit z tending to pi z minus pi upon z sin z, upon z sin z. If you put pi here, what you will get? 0 by 0 form. What you can do? You can apply the L'Hopital rule. Since it is becoming 0 by 0 form, what I am doing? I am applying L'Hopital rule. So upper one, differentiation of upper one will be 1. Differentiation of the downward one, what that would be? First as it is, differentiation of sinusoid will be cosinusoid, plus second as it is, this is the scenario. Now z equals to pi you put, what answer are you getting? Minus 1 by pi is the answer I am getting. What is the answer you are getting? Minus 1 by pi. This is your R2. There could be another method as well. What is that? Sir, numerator as it is, 1 as it is, and differentiation of the denominator, and then you put z tending to pi. This method also you could have applied. Sir, there are two methods. No, if I don't want to follow this method, what is the method that you have told? Numerator as it is, differentiation of the denominator. So sir, I will get this expression only. Numerator as it is, differentiation of the denominator, limit z tending to pi, I would get this expression only, I would get the answer. But one more method I am saying. One more method I am saying. Here what I can do is that, what did I tell you? That in the denominator, no, you put numerator anything, in the denominator put the point which is creating the problem. So z equals to pi is creating the problem. So this guy is creating the problem or not in the denominator? At z equals to pi, 1 by z will throw the value 1 by pi. Not a problem for me. But sir, sin z is throwing value 0, no? Sin z will throw the value sin pi, which is 0. So in the denominator, sin z is actually creating the problem. 1 by z is not creating any problem for me. So I will take it in the numerator. No, why? What is the issue? Let's take it in the numerator and keep it like this. Is that understandable to you or not? I told you one thing, in the numerator you keep as it is. In the denominator you put those points, you make sure that those points are put which is creating the problem. Even if you put z in the denominator, no, there is no issue. You are getting the correct answer. But why to put in the denominator? Now what I can do, sir? For me, now the residue will become very easy. Why is that so, sir? Because I know that, sir, at z tending to pi, I need to find out numerator as it is, differentiation. There you go. Job done. Now simply put pi, what is the answer? Minus 1 by pi. Because cos pi is minus 1 by pi. And now this expression I can use for z tending to minus pi as well. I can use it for z tending to minus pi as well, minus 2 pi as well, and 2 pi as well. Why is that so? Because nowhere you're at minus pi or at 2 pi or minus 2 pi, nowhere your 1 by z is creating any problem. 1 by z is saying no problem there. I am not coming in the singularity. So 1 by z was only creating the problem only at z equals to 0. So here he did whatever he could do. He said that I will become multiple pole, I will make your calculation difficult, I will do this thing, that thing, but only at z equals to 0. At z equals to pi, 2 pi, minus 2 pi, everywhere he is silent. So he would say keep me as it is, keep 1 by z as it is, and differentiate the denominator and be happy. This is what he will say, right? So R2 will be minus 1 by pi. Let me know what will be R3. I am saying R3 will be related to this guy, R4 will be related to this guy, and R5 will be related to this guy. So let me know what will be your R3. So R3 would say that minus 1 by pi divided by cos of minus pi. What is cos of minus pi? Sir, cos of minus pi is also minus 1. So answer will come out to be 1 by pi. Minus 1 by pi, and this value is minus 1. So answer is 1 by pi. What will be R4? So R4, what R4 will say? Numerator as it is. What is numerator? 1 by 2 pi. 1 by z as it is. You need to put z equals to 2 pi, and cos 2 pi is 1. So what is the answer? 1 by 2 pi. What about R5? Numerator as it is. Numerator as it is means minus 1 by 2 pi, numerator as it is, divided by, in place of z, what you need to put? In place of z, you need to put this thing. So what is the value? 1 only. So what is the answer? Minus 1 by 2 pi. So just by using this expression, I wrote down all other answer as well. So what is my summation? R is coming out to be 1 by 2 pi, minus 1 by 2 pi, 1 by pi, minus 1 by pi, plus 0. So summation R is actually 0 only. Okay, so this was the beauty of this question. This is the answer. Is that understandable to you? Although in the examination they asked only at z equals to 0. So z equals to 0, yes, it was a good problem for z equals to 0. You will say that, sir, z equals to 0 will be a multiple pole, not a single pole. It looks like a single pole, but actually it is a multiple pole only. So what I would do is that, sir, I will multiply. I would multiply with z square, then whatever the function I am getting, I will differentiate it with respect to z, and then I will divide it by 1 factorial, and I will solve it in this way. Then I am getting residue equals to 0. Then, sir, other guys are also there, but 1 by z is saying that I am not creating any problem. So you keep me as it is. No, if I am not creating any problem, you keep me as it is. So you keep me as it is and differentiate the denominator, and then you put your z tending to pi, z tending to 2 pi, z tending to minus pi, z tending to minus 2 pi. Understandable? Let's solve the next question. This is the last one. Yes, last question it is. Who is creating the problem? Z equals to 0 is creating the problem, but only once, right? Not only once, twice. It is creating the problem twice, right? What is your function? F of z is sin z by z square. Sin z by z square. So here your poles are there at z equals to 0 and z equals to 0. Here are your poles. Someone would say that, sir, z equals to 0 could be a removable singularity as well. Sir, this could be a removable singularity, and sir, this guy is your simple pole. Someone can say in this manner. Someone would say that, sir, if I put z tending to 0, no, limit z tending to 0 here. What is the answer you are getting? Sin z divided by z square it is. Sin z by z is 1, but sin z by z square is not 1. So someone would say that, sir, I will apply L'Hopital. So it will become cos z divided by 2z. If I put the limit now, what you are getting? Cos 0 is 1 divided by 2 into 0. What is the answer? Infinity. It is does not exist. Does not exist. So you thought that, sir, z equals to 0 could be a removable singularity, but is it coming out to be removable singularity? No. You saw the expression of, sir, sin z by z. So you thought that, sir, z equals to 0 could be a removable singularity, but is it coming out to be removable singularity? No. It is not coming out to be removable singularity. Because what is the condition of removable singularity? That limit z tending to my removable singularity, f of z should give me a finite value. That means it should get cancelled out. It will not get cancelled out, no? Like if it was sin z by z, then you would say that, sir, if I put my denominator equals to 0, no, then z equals to 0 will create the problem. Now you would say, sir, it is removable. Why it is removable? Because, sir, sin z divided by z. If I put limit z tending to 0, what answer I will be getting? Sin 0 by 0, that would come out to be 1, because this limit we already know that is 1. But in the examination, you don't need to think too much. What they are supposed to find out? We are supposed to find out residue. Now you already know that, sir, whatever the method that we have studied, this particular method that we have studied, this method is always true for all kind of singularity, whether it is simple pole, whether it is simple pole, or it is multiple pole, or it is removable pole. For everyone it is true, no? Say yes or no? For removable pole singularity, what we did? We did the same method actually. We took the example of sin z by z. Then what we did? So z equals to 0 is creating the problem. Then what we did was limit z tending to 0. Then if this is creating the problem, remove it and then put limit z tending to 0. What is the answer you are getting? 0. So there I said that residue for all the removable singularity is 0 only. So method was same, no? For the multiple pole as well, for the single pole as well, there is the same method. N will be equals to 1 there. So you are differentiating 0 time. And n will be equals to 1 here. So 1 by 0 factorial will be also 1. So that is also same. So for all these singularities, the same method is there. For essential singularity, there is a method of expansion. For essential singularity, you need to do the expansion. Whether it is removable, simple pole or multiple pole, all will have this same method, no? So in the examination, will you have to think that, sir, whether it is removable or not? You only need to think one thing, that, sir, it is a pole. Sir, I got these values by making the denominator equals to 0. Nothing else you need to think. So since it is repeating twice, what I will say? It is multiple pole. It is your multiple pole. This is what I will say. Since it is my multiple pole, what method I can apply? So the method says that your residue will be nothing but limit z tending to 0. So it is repeated twice, then you will have to divide with 1 factorial. You will have to differentiate 1 times as well. And what you will differentiate with? Sir, whoever is creating the problem now, remove that. So this guy will be removed, or you can say z square f of z. What you will be getting? Limit z tending to 0 d by dz of z square f of z, that would be sin z. So limit z tending to 0, differentiation of sin z will become cos z. You put cos 0, answer will be 1. So there you go. This will be the answer. Say yes or no. Okay. So answer would be 1 here. Understandable? Now there might be someone who can say that, sir, z equals to 0, or there would be method 2. Here what I am saying, that he would say that, sir, yes, 2 zeros are there, because if I put denominator equals to 0, then z equals to 0 and z equals to 0 I am getting. Sir, one of the 0 is for me, one of the 0 is removable singularity. One of the 0 is removable singularity and one of the 0 is simple pole for me. Someone would argue in this manner that, sir, this is simple pole and this is removable for me. So for removable, what will be the residue? So that would be equals to 0, that I already know. And for simple pole, what will be the residue? That I need to find out. So for simple pole, how will you find out the residue? So for simple pole, what do they say? You are finding at z equals to 0, so z tending to 0. Z f of z. What you are getting? Limit z tending to 0. Z f of z. What is f of z? Sin z by z square. Multiply. What answer you are getting? Sin z, z, sin z by z. What is the answer are you getting? Answer is 1. There you go. Okay. So limit z tending to 0, sin z by z. Answer is coming out to be 1. So what is the value of R2 you are getting? So value of R2 I am getting 1. So value of R1 is 0. Value of R2 is 1. So what is the summation? Summation is coming out to be 1 only. Which was same only. Which was same. At different zeros you find out, actually the summation is coming out to be same only. Which was 1 only. This was 1 only. Are you able to understand this point? Say yes or no. Understandable? Let me take one more example. One more example I am taking. Let's take the question of f of z equals to. Let me pause the video and think of the example. Okay. Let me pause the video and think of it. Yeah. So this is the question. F of z equals to sin z by z cube. Then your z equals to 0. Two options you are having. It is a pole of order 2 or pole of order 3. This is the question. What would be your answer? Sir, f of z equals to sin z by z cube is given. Sir, if I put denominator equals to 0, so z cube equals to 0 will create the problem, sir. So z equals to 0, 0, 0. So sir, 0 is occurring 3 times. So it might be a pole of order 3, multiple pole of order 3, pole of order 3. So sir, I will click on this option. It is wrong actually. This is wrong. But sir, previously only you considered it as a multiple pole of order 2. You solved the question. You got the correct answer 1. But I solved it in this way as well. No, z equals to 0 is removable. It is a simple pole. Then also I got a correct answer. Here also I got the same thing. No, for removable pole it was 0. For simple pole it was coming out to be 1. Total it is 1 only. Here I considered it as a multiple of order 2. I applied this method. Answer is 1. Whether it is a multiple pole or simple pole or removable pole, method is same for all three. Whether it is simple pole or removable pole or it is your multiple pole, for all three there is only one formula, which is this. Someone would say that sir, we have another formula for our simple pole. Yes sir, we have another formula, numerator as it is, differentiation of denominator, but this has come from here only. No, it has come from here only. From here only it has been derived. So method is same for all three. Method is same. Now how you can say that sir, it is not a order, it is not a pole of order 3? How you can say so? So correct way of understanding it is f of z equals to, what you would do, you would expand this. What is sin z? What is the expansion of sin z? Sir, expansion of sin z is z minus z cube by 3 factorial plus z to the power 5 by 5 factorial minus z to the power 7 by 7 factorial and so on, divided by z cube, divided by z cube. So what will be your f of z? So now my f of z will come out to be z divided by z cube would be 1 by z square minus 1 by 3 factorial plus z square by 5 factorial minus z to the power 4 by 7 factorial and so on. You see this expression. In this expression, who is creating the problem? Sir, you know that sir, this guy will create the problem. That means sir, z square equals to 0 will create the problem. So z equals to 0, 0, pole of order 2. First of all, is it an essential pole? Sorry, is it an essential singularity? No. What is the meaning of essential singularity? Sir, that sir, 1 by z to the power infinity should have been there. Are you getting 1 by z to the power infinity? No. 1 by z to the maximum power is 2 only. You are not getting 1 by z to the power 4, 1 by z to the power 8, 1 by z to the power 16, 1 by z to the power 97, 1 by z to the power 1000. All these things you are not getting. The expansion is having z to the power 2, z to the power 4, but 1 by z to the power infinity you are not getting. So surely it is not an essential pole. It is a multiple pole only, but of order 2. What it is said is that these are the poles, but this 1, 0 is removable. Sin z by z would be becoming limit z tending to 0, limit z tending to 0, sin z by z would be becoming 1. This would be becoming 1. So one of the 0, no, one of the 0 is going into removable singularity. Removable singularity. Removable singularity. Okay. Now sir, what I will have to do in the, if this question is coming, now sir, I need to find out the residue. This question is coming, you need to find out the residue. The same question, f of z equals to sin z by z cube. Sir, I need to find out the residue. So what I will consider, sir? Should I consider the pole of order 2 or should I consider the pole of order 3? What you need to find out? You need to find out the residue. Now the question would be that, sir, should I consider pole of order 2 or order 3? So if you consider pole of order 2 or pole of order 3, both will give you the same result. Z equals to 0, 0, 0. Okay. Let's understand first way. Z equals to 0, 0, 0. So here I am considering pole of order 2. Pole of order 2. And this is your removable singularity. This is your removable singularity. This is your removable singularity. So for removable singularity, you already know that, sir, residue will come out to be 0. And for pole of order 2, what will be the, for pole of order 2, what is the method? Sir, for the pole of order 2, so the method is residue would be order 2 it is, no? So 1 by 1 factorial d by dz z square f of z, right? Because you are finding out at z tending to 0. You are finding out at z tending to 0. Limit z tending to 0. Z square f of z. Sin z by z cube. So what you are getting? Limit z tending to 0. Limit z tending to 0 and differentiation of sin z by z, right? So what you are getting? Differentiation of sin z by z, limit z tending to 0. So limit z tending to 0, z square z, differentiation of sin z will be cos z minus sin z. Put z tending to 0 here, 0 by 0 form you are getting. That means again first one as it is, sin z minus cos z I am just doing the differentiation on upper side and downward side, divided by 2z. It would be plus actually. So now it is coming out to be 0 only. Residue is coming out to be 0 only here as well. This was your R2. You just need to find out the limit. This limit you can find out. This differentiation you can do. When I did the differentiation, what I am getting? Z square z, differentiation of sin will be cos plus, एक तो भाई ये मेरी खराब आदत है, नहीं ये सही है, हाँ, minus sin z and then 1. Now if I put the limit here, what it is becoming? It is becoming 0 by 0 form. It is becoming 0 by 0 form. So I will apply the L'Hopital rule. So differentiation downward will be 2z. Differentiation on the upper side would be first one as it is. Differentiation of cos z would be minus sin z plus cos z as it is. Differentiation of z would be 1 minus differentiation of sin z would be cos z. You put z tending to 0. This and this is getting cancelled out here. Z and z is getting cancelled out. Minus sin z divided by 2. You put z tending to 0. Answer is 0. So both of the residues are coming out to be 0. So total residue is 0 only. Total residue is 0. Okay, total residue is coming out to be 0 only. Now someone might say that, sir, total residue is coming out to be 0. Now someone would be saying that, sir, I will solve it in this way, that I will consider it pole of order. My second way would be that my f of z is sin z by z cube. I will consider z equals to 0, 0, 0. So it is your multiple pole of order 3. Pole of order 3 I will consider. Pole of order equals to 3. So what will be my residue? So residue will come out to be limit z tending to 0. Limit z tending to 0. Sir, since it is a pole of order 3, what I will have to do? I will have to divide with limit z tending to 0. Pole of order 3, that means I will have to divide with 2 factorial and then I will have to differentiate twice, and this z cube will create the problem, it will be gone. So what you are left with? Sin z only. So this is the process I need to do. So if you differentiate, what answer you will be getting? Limit z tending to 0, it will come out to be minus sin z divided by 2 factorial. Z tending to 0 you put here, 0 is the answer. So what is the residue you are getting? Residue you are getting is 0 only. That's the answer you are getting. Okay, so in both of the cases the residue is coming out to be 0 only. Similar thing we have done here. Here also the residue is coming out to be same. Here also residue was 1 and here also residue was 1. No matter whichever the method you apply, whether you consider it as a multiple pole or you consider them as a one simple pole and one removable pole, both are giving you the same result. But in the examination, if this question is being asked, no, that it is a pole of order 2 or pole of order 3, then you will do, either you can think intuitively that, sir, one of them will be removable and sir other two would be poles. Okay, or what you do is that you do the expansion. When you do the expansion, you see that z equals to 0 is coming out to be a, z equals to 0 is repeated twice here, because one of the z, your sin z is eating up. Basically from here, this one of the z is being cancelled out, no? So one of the z your sin z is eating up. He will say that, sir, z tending to 0, sin z by z is becoming 1 only. That means z square is your pole. Okay, so z square is actually your pole here. So that means z equals to 0 will be pole of order 2. So this option would be correct here, not the other one. But if you need to find out the residue, then you don't need to think anything. Whether you treat it as an order of 3 or you treat it as an order of 2 and one of them is removable singularity, both will give the same results. Okay, So there in the examination, if I need to find out the residue, I will not think anything. I will simply apply this method, that I will consider them pole of order 3. I will simply consider them pole of order 3 and I will apply my method. Here as well I will do the same thing. I will consider them pole of order 2, multiple pole of order 2. I will apply my method. I will get the answer. In the examination I will not think anything, but who knows, if this kind of question they are asking, no, then I will have to think. Then I will have to do the expansion and then I will tell the answer. But in the examination, if they are asking these kind of things, no, what kind of things? These kind of things, that you find out the residue, or here this expression find out the residue. So here I will not think anything. I will tell the answer directly. I hope you are able to understand. Okay. In the next lecture, we are going to study about complex integral. So this lecture is done. Next lecture we will get started and study about complex integral. Understandable? Now do you remember something? Here your concept of vector calculus will be used. Concept of vector calculus will be used in the complex integral. So let's meet in the next lecture. Thank you very much.